Locating the North Star is quite easy on a clear night. The only thing you need to do is find the Big Dipper. Those two stars on the end of the Dipper's cup point the way to the North Star. See? It's the tip of the handle of the Little Dipper, or the tail of the Little Bear. It's in the constellation Ursa Minor, over there. People have been watching the North Star for centuries. This bright star is also known as Polaris. It's situated almost directly over our planet's North Pole, which makes it a great landmark for a traveler without a compass or GPS on their smartphone. It's also Earth's closest Cepheid. That's what we call a star that pulses regularly in brightness and diameter. Polaris is also part of a binary system of two stars. It's got a dimmer sister. It's known as Polaris B. You can actually see it circling the North Stars from Earth. But the more astronomers watch Polaris, the less they understand. The problem is, no one can agree on how big or distant the star is. Scientists have several ways to estimate the mass, age, and distance of a star like Polaris. One method is called the stellar evolution method. After studying the brightness, color, and rate of pulsation of a star, experts use this data to figure out how bright or big it is, as well as what stage of life it's in. Once these details are clear, it's not hard to find out how far a star actually is. It's simple math once you know the luminosity of a star in real life and how dim it looks from our planet. Such models are especially precise for stars like Polaris because the rate of their pulsing is directly related to their brightness. This makes it easy to figure out the distance to any of those stars. Astronomers trust this method so much that Cepheids have become an important tool for measuring distances all across the universe. At the same time, there are other ways to study the North Star, and they don't agree with the stellar evolution models. Polaris is a so-called astrometric binary. It means you can see its companion going around it. It looks as if a circle is being drawn around the bigger star. To complete one orbit, the smaller star needs around 26 years. Even though astronomers haven't made detailed observations of Polaris B's full circuit, they've seen enough to know what its orbit looks like. Using this information, one can apply Newton's laws of gravity to calculate the masses of the two stars. Combined with the Hubble Space Telescope's new measurements, these calculations lead to very precise numbers. Polaris is supposed to be around 3.45 times the mass of the Sun, but that's much less than the mass you get from stellar evolution models. They suggest a value of almost 7 times the mass of the Sun. But there's another reason why this star system is weird. After calculating the ages of the stars, researchers concluded that Polaris B is much older than its bigger sibling. But it's extremely unusual for a binary system. Normally, both stars are of the same age. One explanation might be that at least one of the measurements is simply wrong. After all, Polaris is a difficult star to study. Since it's positioned above our planet's North Pole, it's outside the field of view of most telescopes. As for those telescopes that do have the needed equipment for measuring the star's properties precisely, they're typically used for studying much more distant and fainter stars. Polaris is simply too bright for such instruments. It blinds them. There's a theory that the main star of the Polaris system was once two stars, but they collided a few million years ago. Such a binary collision could rejuvenate stars by pulling in extra material and making the stars look as if they went through the fountain of youth. It would also explain some other oddities since stars that appear as a result of binary collisions don't fit stellar evolution models. Unfortunately, so far, none of the theories has been confirmed. The North Star is actually a big deal. Earth is spinning non-stop, which causes the sun to rise and set and stars to travel across the sky. Our planet is also tilted. That's why we have seasons. If we drew a line through the axis, Earth spins around and extended it for over 300 light years past the North Pole. At the end of that imaginary line, there would be the North Star. It stays almost exactly at the same spot in the sky at all times and always points the way north. It's really important for navigation. People heavily relied on it in the days before GPS. If you were standing on the equator, Polaris would be right at the horizon. At the North Pole, it would seem to be right over your head. In other words, using the star's height in the sky, you can not only figure out the needed direction, but also understand where you are on Earth. Curiously, there's no South Star. There isn't a bright enough star right above the South Pole. But one day, we might get such a star. When you spin a top on the table, its end moves in a circle. We know this phenomenon as precession. Earth behaves in the same way, and the North and South poles won't always point toward the same spots in the sky. In the next 26,000 years, it may cause the North Star to change from Polaris to a few other stars and back again. One day, the title of the North Star will go to Vega. It's the 5th brightest star in the night sky and the 2nd brightest in the northern celestial hemisphere. Vega has another name, Alpha Lyrae. That's because it's the main star of the Lyra constellation. Vega has been one of the most crucial stars to people since ancient times. It's very bright and blue, hence very recognizable. Vega was the North Star several thousand years ago, and it will regain this status in 12,000 years or so. This star is located a mere 25 light-years from Earth. It's just 450 million years old, which makes it way younger than our own 4.6 billion-year-old solar system. Astronomers study Vega to learn more about star systems in the early stages of their formation. Vega is almost directly overhead at mid-northern latitudes on a summer night. It hides behind the horizon for only 7 hours a day. You can see it on any night of the year. If you travel farther south, you'll find out that Vega lies below the horizon for longer periods of time. But in Alaska, northern Canada, and some parts of Europe, Vega never sets. Vega's blue-white light is bright enough to be featured a lot in ancient cultures, from the Chinese to the Polynesians to the Hindus. Vega's name can also be translated as falling or swooping. This is a reference to the times when people regarded this constellation as a swooping vulture, not a lyre. Vega was also the first star to get photographed, other than the Sun, of course. To do it, astronomers at Harvard College Observatory used a 38 centimeters refractor, and it happened in 1850. Around 2 decades later, an amateur astronomer broke down Vega's light to reveal various elements making up the star. In 2006, thanks to telescopic observations, scientists found out that Vega was whipping around so fast that its poles were several thousand degrees warmer than its equator. The star rotates every 12.5 hours and is at 90% of its critical rotation speed. That's the velocity at which an object can tear itself apart. In 2013, researchers announced that they had discovered an asteroid belt around Vega. It means there might be planets somewhere out there among space rocks. There are 2 areas, an outer region that contains icy asteroids and an inner region with warmer space rocks. Scientists can examine bright stars like Vega using NASA's mission called TESS, which stands for Transiting Exoplanet Survey Satellite. It was launched in 2018 to conduct an all-sky survey. The main goal of this mission is to search for exoplanets, but the satellite can also look for star variability. By examining such stars as Vega, TESS can help scientists learn more about the early stages of star evolution. It's the year 2031, and the first human has just set foot on the red surface of Mars. It was a long flight that lasted 172 days. It was a tough journey. There were lots of technical issues. There were some physiological obstacles. Astronauts had to deliver tons of equipment and energy, generating and life-supporting systems to the red planet. Those responsible for the mission had to understand how to deal with low-pressure atmosphere and catastrophic sandstorms, how to keep people safe on Mars's surface, and how to bring them back to Earth after their work is done. It does sound like a science fiction story, but soon it's going to be our reality. But the coolest thing? It's not the limit. After exploring Mars, people might set even more ambitious goals, and this is what some of them may look like. The next planet to visit could be Venus, but it would be a challenging task. Venus is also called the morning or evening star, all because it shines so brightly in Earth's sky that it's the first one to appear after sunset and the last one to vanish after sunrise. But in terms of exploration, Venus is very unfriendly to humans. Its atmospheric pressure is about 92 times as great as the pressure on Earth. And the temperatures on its surface, on average, 850 degrees Fahrenheit. Modern technologies wouldn't allow us to build an infrastructure that would allow people to survive on the planet for longer than a couple of minutes. But then, why would we set sail for Venus? Here's a curious thing. At the height of 30 to 40 miles above the surface of the planet, there are the most Earth-like conditions in the entire solar system. The pressure there is almost the same as in the mountains on Earth, and the temperatures range from 70 to 85 degrees Fahrenheit. If the planet's atmosphere was made up of oxygen and not toxic gases, we could live there without any additional equipment. Or, we could go to Phobos and Deimos. Those are Mars' moons. It would be the first time humans set foot on the moon of some other planet. Phobos is located a mere 3,700 miles away from the surface of the red planet. It would take no longer than a day to reach it. This potato-shaped piece of rock is quite small, a mere 13 miles across. This is the reason why it has very weak gravity. Deimos is a bit farther away from Mars, about 15,000 miles, but this mini-moon is even smaller than Phobos. It's a bit more than 7 miles across. In other words, visiting these moons wouldn't be unlike landing on an asteroid, and the greatest challenge astronauts would face would be leaving the surface of Mars. To do it, they would need loads of fuel. So, most likely, the first trips to Phobos and Deimos would be launched from space stations orbiting Mars. We could set an even more ambitious goal and head for Jupiter and its moons. The distance between this gas giant and our home planet is 365 to 600 million miles. This distance can be so different because the planets follow their elliptical orbits around the Sun, getting closer, then farther apart. The minimal distance occurs every 13 months. If people set off on this long journey during this period of time, it would still take them about 2 years to get there. Since Jupiter is mostly gas, on-planet exploration wouldn't be possible. We could probably fly around the largest planet in the solar system and even dive into its atmosphere. But much more interesting for exploration objects would be Jupiter's moons. Let's say Europa. This natural satellite has a water ice crust. It can be from 10 to 15 miles thick. Under this crust, there might be liquid water. The core of the moon might consist of liquid metal inside a rocky shell. Its super thin atmosphere contains some oxygen. Considering all this, it would be a rather comfortable place for people to explore, if not for its temperature. It doesn't rise above 240 degrees Fahrenheit. We could visit another Jupiter's moon that is called Ganymede. It's an ice satellite with a very thin atmosphere that contains oxygen, or Callisto. It's the second largest among Jupiter's moons. Its icy crust is about 124 miles thick, and it's very cold on the moon, around 220 degrees Fahrenheit. People could also send an expedition to Saturn and its moons. For example, Titan or Rhea. The gas giant itself is twice as far away from Earth as Jupiter. It means it would take astronauts more than 3 years to get to this planet. But if the spaceship was launched from a space station on Mars, it could reduce the travel time by 25 to 50%. But even if the starting point of this expedition was Earth, with advanced technologies like nuclear thermal propulsion, such a journey could take just a year or even less. Saturn can't be explored directly, so researchers would probably start with its largest moon, Titan. It's also the second largest moon in the solar system. This natural satellite has an atmosphere that mostly consists of nitrogen. The pressure on its surface is twice higher than that on Earth. There are winds and rain on Titan, lakes, and rivers. But those consist of liquid ethane and methane, rather than water. It's actually a good thing. We'd have a lot of resources to produce fuel and energy. Rhea is the second largest of Saturn's moons. It's made up mostly of water ice. Its atmosphere is super thin, but it also has some oxygen in it. Actually, all the largest moons of Saturn have only one serious drawback. It's freezing cold there.
On the bright side, they all have plenty of resources to produce energy and other life-sustaining elements, and it would be much easier and faster than the same process on Mars.
But what if we could explore exoplanets? Those are planets that travel outside our solar system. If we managed to get so far away from Earth, maybe we would reach some potentially habitable worlds. It could be Proxima Centauri b. It's the closest to Earth exoplanet, and recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun.
Proxima Centauri b is in the middle of the star's habitable zone.
This means that the chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. It means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star, so the radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. It would take way longer to reach potentially habitable Gliese 832c. This exoplanet is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. Gliese 832c is 5 times as massive as Earth, and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this parent star is a red dwarf, it's much cooler and dimmer than the Sun. So, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that unfortunately, Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. Are ready to test your knowledge? Of course you are! You'll get 1 point for each correct answer. Without further ado, here our Salam cites you. The sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you will get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it will look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then, why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they are the only ones that make it far to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around the meteorite, they think it's super hot. This is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, you know? But don't meteorites fall to Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outer side catches fire, but that layer is blown off on impact as a result of landing on Earth. As you would probably guess when they land, the meteorites are lukewarm at most, but not hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on! First the sun and now the moon. Am I living in a lie? Ha ha ha. So, people look at the sky and see only the bright side of the moon. The reality is the sun shines equally on all sides of the moon as it rotates and orbits the Earth. Half of the moon is in shadow, and half gets the sunshine similar to the Earth. That's not true. Similar to Earth, it doesn't have a permanent dark side. The logic is simple. The moon orbits Earth, but it also rotates on its own axis. When you think about it, we're always looking at the same side of the moon. Black holes take in everything that comes their way. What is it, myth or fact? Black holes don't have infinite mass and gravitational force, but still, no one really knows for sure what happens to the things pulled into them. Experts do know black holes do not have supergravity though. Let's imagine this. If there was a black hole as big as the sun, it wouldn't immediately eat the whole planet. Imagine black holes as vacuum cleaners. It does draw in a cloud of dust near its range, but other specks of dust remain where they are. So even if there was a black hole replacing the sun, all the planets would continue to orbit similarly. They wouldn't go into the black hole. If a star or something else got into the range of the black hole, only then would its gravity affect the star. When you call someone, the signal bounces off a satellite. Is this a myth or a fact? It's a myth, or rather, an urban legend or misconception, you name it. I mean, there are some satellite phones, but we, regular people, don't use those every day, although your mobile phone works in a much different way. When you call someone, the nearest tower connects you to the other person online. This is why there are tower connections, huge networks of tower-to-tower connections, and hidden cables. The moon has no gravity. Any guesses? Myth or fact? This is an urban legend. Ask any astronaut you know. If you don't know any, just trust me. There is footage proving that the moon has gravity. When I say the moon has gravity, don't think it's similar to the gravity on Earth that makes an apple fall. The moon's gravity is only about 1/106th of Earth's. How does it feel to walk on the surface of the moon? The second man on the moon, Buzz Aldrin, mentioned it's like moving in slow motion and perhaps not too far from a trampoline, but without the springiness and instability. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish, watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moonquakes. Does it sound like a myth or a fact? Fact. Quakes happen on the moon too, and they are called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, 55 Cancri E, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the sun. Do you think this is a myth or a fact? This is a fact. Although the sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here, but it's only because it's so far away from Earth. All comets have tails. Myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? I know it was too easy. This is a fact. Space doesn't have an atmosphere, so there is no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the sun. So this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system and the second planet from the Sun. But the distance from the Sun isn't what defines the temperature. The heat depends on the atmosphere. So, Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 degrees. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The Sun rises in the west, and its rotation is very slow. Venus needs 225 Earth days to complete its spinning around the Sun. The planet's distance from the Sun affects the duration of one rotation. It's too close to the Sun, and the Sun has a strong, noticeable pull on the planets. Footprints on the Moon can stay there for millions of years. Do you think this is a fact or a myth? Fact-checked. The Moon has no atmosphere, so there is no wind blowing. Without the wind, there is no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments. You're gazing up at the night sky. Wow. For much of our history, we've been looking for life among these stars and the planets near them. But space has eyes too, and there's someone out there looking at us, maybe. Scientists claim that at least 29 distant planets may be watching us right now. So comb your hair and smile. We've so far identified at least 1,715 neighboring star systems in the Milky Way that can detect our planet with conventional telescopes. These stars are located in our galaxy, so if they were to point their telescopes at our Sun, sooner or later, they would see a small dot that passes between our home star and the observer. This is called a Earth transit. It's a method of detecting planets in astronomy. For example, you can observe transit phenomena right at home with a telescope. Use solar filter. You have to point it at the Sun and wait. Then you'll see Mercury. That's the closest planet to the Sun. And now you see it as a small dot. Mercury transit process can last about 5 hours. And this phenomenon happens about 14 times in a century. You'll be able to observe the next transit on November 13th, 2032. Mark your calendar. Likewise, you can observe Venus, the second planet from the Sun. But because it's farther away, its transits are less frequent. The last one was in 2004 and 2012. The next pair of transits is expected in 2117 and 2125. Hey, I won't be around then. So these star systems have the opportunity to observe our planet. But long-range telescopes work a little differently. Actually, the observer will not see a black dot with the Sun in the background. The telescope will measure the brightness of our star. When Earth begins its transit light time between the Sun and the observer, the telescope will record a slight drop in the brightness of the star because our planet is blocking the path of the Sun's rays. Those faraway scientists of extraterrestrial civilizations will be able to calculate this drop in brightness and determine the size of our planet. But not all 1,700 plus star systems may have extraterrestrial life. Scientists have narrowed it down to 29 planets near some of these stars. They're potentially habitable. That means these planets are roughly Earth-like in size and within the habitable zone of their host star. That means they're not too close to the star, so it's not too hot for potential life. The water doesn't evaporate there like in a boiling pot, and they're not too far away, so it's not too cold and the water doesn't freeze into thick sheets of ice. And since water is the basis of life, we can assume that civilization might exist there. Theoretically, these planets could have seen Earth transits in the last 5,000 years. So while we were building the pyramids of Giza or Stonehenge, an extraterrestrial civilization may have been watching us. One of these planets is only 11 light years away from our home home near the Ross 128 star, a red dwarf in the constellation Virgo. There's an exoplanet about twice the size of Earth and right in the habitable zone of its host star. Theoretically, the inhabitants of this planet could see Earth transit the sun on a regular basis for 2,000 years, but about 900 years ago, the planet lost its position and can no longer continue observation. The other planet where Earth can be seen transiting is 12.5 light-years away, near the star called Teegarden. The window for observing our planet will open there in about 29 years. We're betting heavily on the TRAPPIST-1 star system. It hosts at least 7 exoplanets, almost like our solar system, and 4 of them are in the habitable zone of the star, but they won't be able to start observing Earth until 16 centuries from now. But we can try to make contact with these planets right now. They're all close enough to us to pick up our radio signals. Radio waves can travel through space at the speed of light, and our planet has been emitting radio signals continuously since 1895. So we're like noisy neighbors in the radio spectrum. If there's a planet somewhere with an intelligent civilization within a 125 light-years of us, our radio noise would have already reached them. The only problem is, it would take about the same time to get a response from that civilization. The other problem with radio is that any civilization uses it for a relatively short period. Even now on Earth, we use Bluetooth and fiber optics more than radio, except for maybe traffic reports. And over time, all the radio noise we create will simply disappear. Also, radio communication assumes that an extraterrestrial civilization is advanced enough to use this technology. But who knows? Maybe there are life forms in space that are really different from ours. Our radio signals already could have reached that planet, but its inhabitants simply aren't capable of receiving them. And the moment these life forms build antennas to receive the signal, we'll no longer emit them. But we don't lose hope, and we even send encrypted radio signals into space to communicate with extraterrestrial civilizations. In 1974, we sent the Arecibo message into interstellar space. If some civilization can decipher it, they'll get a rectangle like this. It has all the information about humanity. At the top is our number system, then the atomic numbers, and then our DNA, which is pictured below. Then, a human being itself, of course. Below is a diagram of our solar system. Earth, the third planet from the sun, is slightly elevated. This is how the extraterrestrial civilization will understand which planet this message came from. Below is a diagram of the Arecibo radio telescope itself. Another option, how to deliver a message to a distant planet, is to literally send a mail delivery there. It could be a space probe, and we've already done that. These are Voyagers 1 and 2. They were launched in 1977 and are still operational. In 2012, Voyager 1 became the first ever human-made object in interstellar space. It travels to distant stars and carries a message written on a golden record. The disc contains greetings in 55 Earth languages, a lot of music from different parts of our planet, different sounds like ocean noise, human voices, and animal sounds. In addition, there are 116 images on the record. There are pictures of people and earthly landscapes. In these pictures, there's information about the sun and our DNA. The record case contains instructions and a needle to play the record. There's also a map of our galaxy's pulsars, so that astronomers from an extraterrestrial civilization can find our solar system. The main disadvantage of sending a message this way is time. Voyager 1 will reach its first stop, the Gliese 445 star, in 40,000 years. Voyager 2 will reach the Ross 248 star in 42,000 years. And in about 296,000 years, it'll pass Sirius, the brightest star in the night sky. I can't wait. Also, an extraterrestrial civilization can detect us with calculations and formulas. All it takes is a little observation of the sun. In star systems with planets, the host star doesn't stand still. It rotates around a small orbit. This is because the heavy star attracts the planet, but the planet also has its own gravity and resists. This shifts the star a little and causes it to orbit around. An extraterrestrial civilization can calculate this shift of the sun and determine the mass of the planets near the star. Using such a method, astronomers were able to find 548 exoplanets. Suppose we made sun contact with an extraterrestrial civilization near the closest star, Proxima Centauri. There's indeed an exoplanet there, but radiation from the host star would destroy any life forms. But imagine if we still got a return signal. It would be the slowest chat in history because our message would take 4.2 years to reach the planet, and we'd have to wait another 4.2 years to get a response. And so we arranged to meet. This civilization doesn't know how to fly into space, so we have to take the first step. Although Proxima Centauri is the closest star to the solar system, it takes about 73,000 years to travel there by conventional rocket. So we have to learn to travel at the speed of light. But even then, it would take 4.2 years to travel there. Imagine if we found extraterrestrial life on the other side of the Milky Way. Our galaxy is 100,000 light years wide, so the journey from edge to edge would take 100 millennia. So we either have to cheat the laws of physics or transfer all of human civilization to a giant spaceship that will travel from star to star for thousands of years. And when it launches from Earth, only the great, and many more greats of the first crew will be able to see another star system from the spaceship porthole. Hey, can you move your head? I'm trying to see out the window. Whoa, something doesn't feel right. Everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second. And they don't know why. Breaking news. The Earth has gone crazy. Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there'll be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function. And mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds. But around the equator, you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stopped since the radar systems have gone haywire. And the weather's too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually, we'll have a total communication blackout. Ships will cease to operate, and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be in danger, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we probably feel like we're always on a jet plane, going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day, so days would be around 7 hours long, as well as nights. The whole world would be flooded except for the highest points in the tallest mountains. If that happens, humans will most likely end up there, clinging on to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters, like earthquakes, tsunamis, volcanoes, and even melting ice sheets, have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour, and as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around. Probably, except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted, and with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry? I hate to break this to you, but money isn't actually made of paper, which also proves that money doesn't actually grow on trees. Most banknotes are 25% linen and 75% cotton, which is why they have such a distinct look and feel. Back in the 19th century, money was made of parchment paper. That's why people could very easily counterfeit it, unlike now. The Eiffel Tower is almost 6 inches taller during the summer. When you heat up some substance, its particles start to move more actively and take up a bigger volume. When the temperature lowers, the substance contracts again. Such an effect is more prominent in gases, but you can also track it in liquids and solids, including iron. If you make a snowball and try to set it on fire using your lighter, the thing won't melt. The snow will first turn black, then it'll start to vanish, but you'll get no water. There's nothing supernatural about this phenomenon. The snow is melting, but you don't see it because of the structure of the snowflakes. They kind of wick away the melted water, and it gets absorbed by the remaining relatively loosely packed snowball. Our moon used to have an atmosphere. Several volcanic eruptions happened on Earth's natural satellite around 4 billion years ago. They released immense volumes of gas, trillions of tons. It was so much that the gas didn't have enough time to escape into space. That's how an atmosphere was formed. Just like a chicken egg, an ostrich egg will contain a chick embryo, only if the egg was first fertilized by a male ostrich. Otherwise, you'll find only whites and huge yolk inside of it. The size of the yolk is equal to around 24 chicken yolks. So, one ostrich egg can easily feed a squad of 10 people. But ostrich eggs aren't all that edible. Those who tried them say that they taste a lot like chicken eggs, fatty, buttery, and kind of sweet. But the flavor is more intense. They're also richer in magnesium and iron than chicken eggs, but contain fewer vitamins A and E. One ostrich egg will give you about 2,000 calories, while the average chicken egg only 75 calories. Cooking and eating them is a chore, so you'll unlikely have them for breakfast every day. Their shell is extremely thick. You can step on the eggs with both of your feet and they won't break. That's why if you want to cook an omelet using an ostrich egg, you're going to need a drill or a hammer, and also a really big skillet to fit an egg of that size. No, bigger. Yeah, like that. Boiling the egg will take almost 90 minutes. Not so long ago, scientists decided the Dinosaurs family tree had to be redrawn for the first time in 130 years. Apparently, 2 species of dinosaurs had to be grouped together from the very beginning. Those were the lizard-hipped meat-eaters, like T-Rex, and bird-hipped vegetarians, such as the Stegosaurus. People are still evolving. Scientists have been tracking several millions of human anomalies. It turns out some harmful genes are slowly but surely getting filtered out of human DNA. Sound travels almost 4 times faster underwater than it does in the air. That's why divers often have problems with figuring out the direction of sound. Bananas contain potassium, and this element is slightly radioactive. On the bright side, you need to eat 10 million bananas before radiation can negatively affect you. Meanwhile, out in space, shadows are darker on the moon than on our planet. That's because the atmosphere on Earth scatters more sunlight. But if you could visit the moon, you'd observe shadows so dark you wouldn't be able to see where you were going. Also, you'd notice fresh footprints on the lunar surface. People haven't set foot there in a few decades, but the footprints look as if they were left just yesterday. Since there's no water or wind on the moon, nothing can erase these footprints, so they can stay there in their original form for millions of years. Sure, if you were about to go to space, one of the first things you'd think of would be your spacesuit. But do you know that it's possible to survive in space even if you aren't wearing any protection? Well, don't get your hopes up yet. you'd last for no more than 15 seconds. That's how long it'd take you to lose consciousness, because oxygen will stop coming to your brain. The ocean performs many important functions. For one thing, it produces 50 to 80% of all the oxygen on our planet, which means it keeps us alive. But it also helps the internet to function. So, when you're laughing at a funny dog video or binge watching your favorite series, Disneyland's airspace has the protection level of the White House and the Kennedy Space Center. It's prohibited to fly over the theme park without a special waiver. The restriction was introduced in 2003 for security reasons, so now you will never see a plane or even a single drone flying over the park. How about a butter applicator in the form of a glue stick? Butter. With this invention, making sandwiches in the morning will become so much easier. The main challenge is not to confuse it with a real glue stick. Bacon lip balm is a great addition to the butter sticks. This product is already being sold online. Imagine rubbing your lips with a piece of fried bacon before going out. Not really my thing, but tastes differ. Bananas are delicious and convenient. Thanks to their dense skin, they don't break when you carry them with you. But for some people, this natural protection doesn't seem to be enough. They don't like brownish marks on the yellow peel, especially for them, one of the main inventions of the 21st century. This is a banana suitcase. The container will protect your banana from the dangers following it everywhere. How can you get your cat to work off the money you spend on its food? Let it clean the room while you're away. Japanese engineers came up with cat duster slippers. The cat walks on the floor and rides your home of dust at the same time. But I'm not sure your pet will like this idea. Hugs are very beneficial to health. They relieve stress and help your body produce endorphins, the hormone of happiness. The image of a happy girl in Wendy's logo was inspired by the daughter of the fast food chain's creator, Dave Thomas. Wendy is her nickname. If you look closer, you'll notice her collar spells out the word mom. Whether intentional or not, it became something to mean a homely feel. The restaurant gives its guests 9:41, set as the time in iPhone's ads, isn't a random choice of numbers. In 2007, Steve Jobs first introduced the iPhone to the public after a 41-minute presentation at exactly 9:41 a.m. The first Apple logo was designed in 1976 and featured Sir Isaac Newton sitting under a tree with an apple about to fall on his head. It seemed too complex and unclear to many, so Steve Jobs wanted it replaced. Some people have a fear of technology, aka technophobia. Now it mostly has to do with complex new devices like computers, but it has its roots back in the time of the Industrial Revolution. It began in the 18th century, when workers were afraid new machines would take their jobs. The founders of Domino's were originally planning to add a dot to the Domino's in the logo for every new place they opened, but it was growing way too fast and too big for that. So they decided to keep just 3 dots for the 3 original locations. Let's do some quick math. A commercial airplane can fly at 575 miles per hour. Our rockets fly into space at 26,400 miles per hour. But this asteroid breaks all records and zooms at 33,000 miles per hour. That's 43 times faster than the speed of sound. At that speed, you could cross the Atlantic Ocean in just 5 minutes. The worst part is that this thing could crash into the Earth. 575 in 926 kp. This is asteroid 2021 RX-9. It's 128 feet wide. That makes it 1/3 the size of football field. It was only recently discovered, and scientists were able to calculate its orbit. It's not round like most planets. It's an ellipse, like if you squeezed a donut a little bit. 128 ft. 40 yards mine. RX-9 begins its journey toward the center of the solar system about 273 million miles from the sun. It crosses the asteroid belt, then the orbit of Mars, and the orbit of Earth. It makes a circle around our star and then shoots back like a slingshot. The asteroid will move away from the sun until the star's gravity forces it to begin its return journey. RX-9 makes one such round trip in 2.5 Earth years. Although the orbit of this asteroid intersects with that of our planet, it's not dangerous to us. But there are many other asteroids in space. RX-9 could collide with them and change its trajectory. Oh, and that could put it on the list of potentially hazardous asteroids. And this thing is asteroid 2021 NY1. and it's already on the list. It's as big as 2 Statues of Liberty, and it's moving through space at 6 miles per second. So this asteroid could take you to the moon in just 11 hours. Its orbit is also elliptical. Its far point lies somewhere between the asteroid belt and Jupiter at X39 Earth-Sun distances. The closest point of its orbit to the Sun is right near the Earth's orbit. Asteroid NY1 has passed Earth at only X4 Earth-Moon distances, X3.9. It'll make a circle around the Sun and head back to its starting position. The asteroid makes a complete orbit in almost 4 Earth years. The record for the closest approach to Earth belongs to asteroid 2020 VT4. It's a rock the size of a bus, and it flew at an altitude of 230 miles above Earth. For comparison, the International Space Station orbits our planet at 250 miles, so it flew literally over our heads in the region of the South Pacific Ocean. And we didn't even know this asteroid existed. It flew over the Earth at daytime, and we couldn't see it because of the sun's light. Scientists only learned about this asteroid 15 hours later. If it had fallen on Earth, well, let's say we could have had a very bad day. Although this asteroid was small, it was moving extremely fast. That gave it a tremendous amount of energy. But we have a shield that protects us from space rocks, our atmosphere. It's full of air particles. When an asteroid enters our atmosphere, it begins to break against these particles because of friction. This heats up the asteroid so much that it begins to burn. This is the reason why the bottoms of our space shuttles were protected with black tiles. They could withstand temperatures up to 2,300 degrees Fahrenheit. So, if an asteroid is small, it could burn up completely in the atmosphere and turn to dust. If you look at it from Earth, it would look like a falling star. Scientists believe that any asteroid under 80 feet in diameter will burn up completely in the atmosphere because but an asteroid larger than 1.5 miles can do a lot of damage, and we know of such an asteroid that regularly passes by our planet. 4E179 Toutatis. It's 3 T herd miles wide, so it's bigger than Central Park in New York. And if you put this rock on scales, it'll show 5 plus 11 zeros tons. That's heavy. The most frightening thing is that this asteroid moves in a chaotic orbit because it's constantly being affected by Earth and Jupiter. It's like the planets are playing ping pong with this giant rock. It also causes the asteroid to rotate like crazy. If you were on the surface of Toutatis, you would see that the sun constantly rises and sets in completely different places. Because of this chaos, scientists can only predict the movement of this asteroid 50 years in advance. In 2004, it came within X4 Earth-Moon distances from our planet. Fortunately, there's a chance that, one day, it'll leave our solar system. Jupiter or Earth will launch it into distant space like a slingshot. But if it did fall to Earth, it would cause gigantic tsunamis and earthquakes all over the planet. Then, the existence of our civilization would be in question. A similar catastrophe happened about 66 million years ago. An asteroid the size of Manhattan flew toward Earth. The sun heated its surface and vaporized the material from it. The dust and steam turned into a giant tail that glowed brightly in the night sky. The night before it fell, it was the brightest object in the sky, perhaps even brighter than the moon. The moment this asteroid entered Earth's atmosphere, it caused a popping noise so powerful that you could hear it on the other side of our planet. It began to burn. Small fragments began to fall from the main body of the meteorite. Some of them burned up completely in the atmosphere, but others fell to the surface. The moment of impact, the mass and speed of the meteorite gave it colossal energy of about 100 teratons in TNT equivalent. That's a big boom. All this energy turned into heat. It was literally a wall of fire that spread around the impact site and burned everything in its path. The blast wave from the touchdown circled our planet several times. It caused a tsunami with waves higher than the Empire State Building, and earthquakes so strong that the ground literally cracked. After this incident, about 95% of all life on Earth ceased to exist. The meteorite left behind a crater as wide as 66 Golden Gate bridges, and it was so deep that you could stick 2 Mount Everests in there. And there are still many objects in the asteroid belt behind Mars that pose a threat to Earth, like Ceres. It's not just any asteroid, it's a dwarf planet. Although it has a mass of only 1% that of the Moon, it gravitationally affects the orbits of Earth and Mars. A collision with an asteroid of that size would simply destroy the Earth, tearing it to pieces. So, humanity must learn how to avoid colliding with dangerous asteroids. Here, we have 2 options: destroy the asteroid, or make it change its trajectory and fly past Earth. Destroying a huge rock that weighs as much as an entire city is difficult, so we stick with the second option. We can send a spaceship with explosives there, and then do a little boom. Only we don't have to drill a hole to plant this present inside the asteroid. The boom has to be right above the surface and pointing upwards. Then, according to the laws of physics, the asteroid will shift down a little bit. Even if the asteroid moves only a few feet on a cosmic scale, this would dramatically change its trajectory. Another option is a gravity tractor. The principle is simple. Any object that has mass also has gravity. Even you. Yes, you have your own gravitational force. So our plan is to send an unmanned spacecraft to the space rock. It would just have to hover over the surface of the asteroid. Then, the space rock will attract the spacecraft, but the craft's engines will resist. As a result, the asteroid itself will start pulling toward the spacecraft. Voila, Earth is saved. We can also use solar power. All we have to do is build a giant space station out of thousands of magnifying lenses and send it to the sun. When we spot a dangerous asteroid, the station will focus the sun's rays on the surface of the asteroid. The ice from its surface will begin to evaporate and move upward. The reactive force will push the asteroid down, or deliver a giant cloak of shiny material, like foil, to the asteroid. If you wrap the asteroid in such material, it'll reflect the sun's rays. Again, the rays are reflected one way and push the asteroid slightly the other way. This method can only work if we have a few years to spare before the asteroid arrives. Another strategy is to attach a solar sail to the asteroid. It would work like a parachute, only it won't be braking against the air, but against the sun's rays. And the simplest option, we could attach conventional rocket engines to the asteroid. Then we can not only change the trajectory of its flight, but also control it. And if a bigger asteroid appears on the horizon, we can use the controlled space rock as a giant ram. I guess it's no surprise that it's not that easy to just hop on a plane and literally fly to the South Pole, aka Antarctica. Sure, there are airports down there, but they're not really set up for commercial flights. So, most people go to Punta Arenas International Airport in southern Patagonia, Chile, and then take a boat if they want to see some penguins. But not only is it hard to fly there, it's even hard to fly over there. When you're cruising at 9,000 meters, you probably don't think much about what's happening below. But it's pretty unusual for flights to go directly over the South Pole, and planes flying across Antarctica are quite rare too. Technically, it is possible. I've already mentioned that there are airports there. But even so, the infrastructure down there is still super limited. There simply aren't enough airports or refueling stations to support regular commercial flights, making it tricky to operate in such a remote area. Plus, there are only a handful of specialized cargo and transport flights that go in and out, and they exist to cater to those few folks who actually live in Antarctica. Then, there's the weather that drives up the costs. The simplest example is that pilots there need special training, which costs money, which is all because of the weather. Another hurdle is something called ETOPS, Extended Twin Engine Operational Performance Standards. These rules dictate how far twin-engine planes can fly from an airport. Since there are so few airports in Antarctica, it's tough for pilots to stick to these regulations. Historically, ETOPS made it next to impossible to fly close to or over the South Pole. While flights over land have plenty of airports to choose from, Antarctica is a whole different ballgame. These days, some aircraft can fly up to 330 minutes, or, in rare cases, even 370 minutes from an airport. But even with those extended limits, certain parts of the airspace above Antarctica are still off limits. Still, in the grand scheme of things, that might not be a huge deal. The most curious of you must have Googled that already and found out that there really are Antarctic Airways. Please, do not judge fast, and do not say I wasn't right saying how hard it was to fly to the South Pole. Let me break it down for you. Antarctic Airways advertise as the world's most exclusive transcontinental flight, but don't think you can just waltz in and book a ticket anytime. For starters, Antarctic Airways mostly operates flights to King George Island from December to March, so it's not all year round. But there are many more reasons why these flights are unique. If you dig into their website, you'll find you've got two choices: a full day in Antarctica or an overnight adventure. Prices kick off at $5,500 for a day trip and go up to $6,500 for an overnight stay. And if you're considering a private charter, get ready to shell out a pretty penny. Sure, that's a steep price compared to your average cruise ship crossing the Drake Passage, but here's the thing. It's about 20 times faster. A cruise ship takes 2 days from Chile, while Antarctic Airways gets you there in just 2 hours. Air travel to Antarctica is pretty limited, likely due to the high costs, limited seating, and the logistical challenges that come with flying to such a remote location. Plus, flights can often be delayed because of bad weather. Most travelers opt for a quick day trip or an overnight stay on King George Island, usually aboard smaller Beechcraft King Air 300 aircraft. The experience typically includes a stroll to a research station and a boat ride to see nearby penguin colonies, but that's just scratching the surface of what Antarctica has to offer. But once you're aboard Antarctic Airways, you'll see it's just like a regular flight on a smaller plane. You'll be served meals that have received some pretty good reviews. There are even photos floating around online showcasing the food, and honestly, it looks awesome! Those who've experienced it say it's luxurious yet unpretentious. You'll get a mix of meats and cheeses, plus treats like tiramisu, salmon salad, a single After Eight chocolate, and a selection of quality street candies. Today, everything may seem cool and safe, but back in the day, there were some pretty tragic events. On November 28, 1979, Air New Zealand Flight 901 tragically collided with Mount Erebus on Ross Island, Antarctica. Unfortunately, all 237 passengers and 20 crew members aboard lost their lives that day. Since 1977, Air New Zealand had been running regular sightseeing flights over Antarctica. This particular flight took off from Auckland Airport in the morning, with plans to spend several hours exploring the stunning Antarctic landscape before heading back to Auckland via Christchurch that evening. Initially, the inquiry into the incident pointed the finger at pilot error. However, growing public concern led to the establishment of a Royal Commission of Inquiry for a deeper investigation. The commission found that the crash had been primarily due to a change in the flight path coordinates made the night before, which the flight crew hadn't been informed about. As a result, instead of being guided by the computer down McMurdo Sound, as they were led to believe, the aircraft was mistakenly redirected toward Mount Erebus. In a way, this flight looks like modern one-day Antarctica tours. Flight 901 was marketed as a unique sightseeing adventure, complete with a knowledgeable Antarctic guide who highlighted various scenic spots and landmarks through the plane's public address system, while passengers enjoyed a low-altitude tour of McMurdo Sound. These flights operated as day trips, taking off from New Zealand and returning on the same day. The plane departed from Auckland International Airport at 8 a.m., aiming to land in Antarctica, with a scheduled return to Christchurch International Airport by 8 p.m. The total journey covered about 8,730 kilometers, including a 45-minute stop in Christchurch for refueling and crew changes, before completing the final 747 kilometers back to Auckland, arriving at 9 p.m. Back in November 1979, tickets for these flights were priced at $359 per person, which is over $2,150 in today's money. Anyway, this tragedy isn't the reason why planes don't fly over the South Pole. The real culprits are weather, ETOPS regulations, and of course, penguins. Yep, Those cool and friendly little creatures. Friendly, at least according to researchers. With no natural predators on land, all of them are in the water. They're not really afraid of people and actually seem to enjoy our company. The South Pole is completely uninhabited and packed with penguins, making it pretty tricky to build anything down there. By the way, the North Pole actually allows planes to fly over it. Not too long ago, there were direct flights from Copenhagen to both LA and Tokyo, operated by SAS, and they cruised right over the North Pole. Other airlines joined in too. For example, Emirates ran a flight from Dubai to LA that took the same route. The difference in air traffic between the two poles mainly comes down to where people live and how much land there is. Roughly 88 to 90% of the world's population hangs out in the northern hemisphere, while only about 10 to 12% call the southern hemisphere home. Most folks in the south are clustered around the equator, in places like Indonesia, Central Africa, and Brazil. When it comes to flights heading to the South Pole, options are pretty limited. You mainly have routes connecting New Zealand and Australia, parts of southern South America, and a few spots in southern Africa, especially South Africa. There aren't really any direct flights over the South Pole, though some flights can get close to Antarctica. One possible route could connect Auckland, New Zealand to Cape Town, South Africa, but there aren't any scheduled flights for that right now. The few flights that come close to Antarctica are operated by Qantas and LATAM Airlines, linking Australia with Buenos Aires and Santiago de Chile. In 2021, Qantas took a long detour over parts of Antarctica on a flight from Buenos Aires to Darwin, and in July 2023, they adjusted a route closer to the continent to dodge some fierce headwinds on a trip from Santiago to Sydney. Perhaps we've all stopped to think at one point about what it would be like to live on a different planet. I know I've had days like that. Gotta get away. And maybe even interact with other types of creatures that already live somewhere else in space. These days, such ideas sound more like something from a science fiction book. But in the future, permanently changing your address to another planet might turn out to be mandatory. Think of the star in our solar system as a battery. Billions of years from now, its energy will be gone. Without its light and warmth, life on Earth can't exist. When you think about it this way, we have to hope that future humans will have found some other place to live by then. Thankfully, there's good news. Recently, scientists at NASA have announced that they found a new planet that might be able to support life. They call it TOI 700e. It's roughly the same size as Earth, and it's located in a region of space where scientists think water could exist in its liquid form, which is crucial for the development of life. This planet is not the only one, though. Close to it, there's another promising planet which they called TOI 700d. But this one is further away from its star. Because of the distance from the main source of light, Planet D lies in a special area called the Conservative Habitable Zone. In simple terms, scientists are not so sure life might exist on this one, but they don't exclude such a possibility. Planet E is in the optimistic zone, which means that it's possible that it has water and even an atmosphere. Hey, at least we have options. The two planets are in a solar system that is only 100 light years away from Earth, which is considered pretty close in space terms. NASA found these planets by watching the light coming from the star and measuring how it moves when a planet passes in front of the star. This is the first time that NASA has found a solar system with multiple planets that could have life. So far, scientists have found over 5,000 exoplanets, and they think there could be at least 10,000 more. Specialists at NASA are looking into the ways to figure out if any of these planets could harbor life. But they also say that we might find forms of life we don't expect to see, and that we should be open to other possibilities. That's because we only know about what life can be by looking at our own planet. Sure, everything sounds enticing so far, but don't pack your bags just yet. As appealing as these new planets might sound, there's still one problem: getting there. Scientists have been researching for decades how people can stay in space,
and thrive for long periods of time, and history tells us it's no easy project. Back in 1962, John Glenn became the first American to orbit our planet. To circle Earth a mere 3 times, he had to go through months of technical and physical preparations. These days, advanced technology helps us investigate Mars better, and scientists have figured out that there is water and materials on the red planet that may be useful to people. It has sparked the idea of sending people to Mars to live there, just to begin with. The first manned Mars mission is scheduled for the late 2030s or early 2040s, if everything goes well. The plan is for this to be a round trip, but even if NASA manages to plan everything well, the round-trip journey will still take about 500 days. It all depends on Mars and Earth's positions in their orbits around the Sun. One of the biggest problems with living on Mars is gravity. For starters, the astronauts will arrive at the red planet after months of living in microgravity. It means it would take them a lot of time to physically get in shape before they could start exploring. That's because living in microgravity conditions heavily affects the human body. It might mean loss of bone and muscle mass, as well as a shift in the normal movement of body fluids, which tend to go upward. This can lead to pressure on the eyes and even problems with people's eyesight. But Mars is right here, in our own solar system. What about planets that are light years away? The answer is still up for debate. It may sound cool to travel really fast, like at the speed of light. So far, scientists believe it's not possible. Sure, we may have been able to create airplanes that travel faster than sound, I mean supersonic aircraft, but it's not the same. There's quite the difference, actually. Light is about 1,000,000 times faster than sound. Traveling at the speed of light would mean we could go from Earth to the Moon in 1 second, or from Los Angeles to New York in less than the blink of an eye. But what stops us, though? Some say it's energy. It may be possible to make something go really fast, but it'll take a whole lot of energy. In this case, engineers will need to find new ways to make things move in space. Right now, rockets use fuel that is similar to the gasoline you use in your car. But that is not very efficient when it comes to space travel. Other ways to push a spacecraft include using electric or magnetic forces. One promising idea is using a solar sail, which is like a large, thin sheet of plastic that can be pushed through space by sunlight. Some spacecraft have already used solar sails, and scientists think they could go at up to 10% of the speed of light. If other planets in our solar system turn out to be inhospitable, and we can't invent spaceships that move fast enough, we might still have a choice. Secret option C. It was first proposed by a scientist who wrote an interesting study about a special type of planet. It suggests that we might not need spaceships to move around and escape problems on our own planet. We could use planets that are not orbiting a star. They're called rogue planets. Ooh, instead of gravitating toward a star, these lonesome space objects simply drift alone through space, doing their own thing. Think about it this way. Moving to Mars is like moving to an already furnished house. Regardless of how nice it would be, you would still have to adapt to it. You'd have to get used to how much light gets through the windows each day, and to climbing up and down the stairs to get to the living room. Moving to a rogue planet means we'd start from scratch, building our own house from the ground up, perfectly adapted to our needs. Free-floating planets are usually seen as cold, dark, and not suitable for life, but if they have underground resources, they can be useful. They offer a constant surface gravity, a lot of space, and resources. They can also provide water and protection from space radiation. If we become an advanced enough civilization, we might be able to control the planet and even create new types of energy. The next question would be where we could find such a rogue planet. It's hard to know how many of these there are in the universe, but scientists have found a bunch of them in one region of the Milky Way galaxy. Some rogue planets might have been kicked out of their own solar systems because they were bad. No, not really. It was because of gravity, while others might have formed on their own. Either way, We don't want rogue planets to get too close either, at least not in the near future. The chances of a rogue planet entering our solar system are extremely low, but if it did, it could mess things up for us. Depending on its size, a rogue space object might divert other planets off their course around the Sun, which could alter their exposure to light and warmth. And if it crashes into the Earth, well then that would a bad thing too. While some astronomical events are pretty common, there are those which occur only once a year or once in 100 years. Let's have a look at the coolest and rarest events we might be able to see with our own eyes. The first amazing celestial event on our list is the Perseid meteor shower that will take place from the 17th of July to the 24th of August 2024. This event is going to be one of the most vibrant of the year. At its peak, between the 12th and 13th of August, you might see up to 100 meteors every hour. If you're in a dark place, that is. This meteor shower is caused by debris from the comet Swift-Tuttle. As meteors streak through Earth's atmosphere, they often leave behind long wakes of light and color. The perfect time for watching this cosmic show is before dawn. On the 2nd of October 2024, we'll be able to watch a ring of fire solar eclipse. Its scientific name is an annular eclipse, and it occurs when the moon is slightly farther away from our planet. In this case, when the disks of the moon and the sun align, the moon's shadow doesn't completely block the sun's light. As a result, you can see a ring of sunlight around the moon. This time, the ring of fire will be visible in southern Chile and southern Argentina, so book your flights early. Another cool event that will occur this October, October 6th to 10th, 2024, is the Draconid meteor shower. During this event, meteors are more likely to fly in the evening hours than in the early morning. This is usually a slow shower, producing just a handful of meteors per hour. On the other hand, astronomers speak of a rare fiery Draco, which has been known to send many hundreds of meteors across the sky within a single hour. Are we going to get lucky this year? Time will show. Starting from the 12th of October, and for the following week, you'll have a chance to see a comet passing by our planet. Even though this nearly unpronounceably named big boy, Tsuchinshan Atlas, will be about 70 million kilometers away from Earth at its closest point, you might be able to see it with the unaided eye. Comets have a reputation of being quite unpredictable. Most of these dusty, icy space bodies are thought to have originated on the outskirts of the solar system millions of years ago. And there, they spent most of their time in the dark, inert and unnoticed, like me in middle school. Now some of them come closer to the sun, and many experts already forecast a fantastic celestial spectacle in October. If you missed the meteor showers we've talked about, you'll be able to catch up. Orionid meteor showers will keep going from the 26th of September till the 22nd of November, 2024. Sometimes this event can produce from 40 to 70 meteors per hour, but recently the maximum number was lower, from 20 to 30 visible meteors. And the final event for this year is going to be the Geminid meteor shower, December 4th to 17th, 2024, and let me tell you, this event is going to be breathtaking. Astronomers claim that this meteor shower is one of the best of the year because of bright, visible meteors. Around 120 shooting stars are likely to streak across the sky per hour. Interestingly, while most meteor showers come from comets consisting of dust and ice, the Geminids originate from a rocky asteroid, 3200 Phaethon. Scientists still don't know how to classify this asteroid since it has a tail and brightens as it comes closer to the sun, just like a comet. On the other hand, recently, astronomers have discovered that the asteroid's tail is made not of dust, but of sodium gas. Now, let's travel farther into the future. In 2029, we'll witness the darkest lunar eclipse of the century. A lunar eclipse occurs when our natural satellite completely hides in Earth's shadow. Sometimes, when it happens, the moon can look bright red. Normally, the closer the moon is to the center of the shadow of our planet, the darker the eclipse is. And according to experts, the eclipse on June 26, 2029 will be extremely dark. It will last for about 1 hour and 42 minutes and will be the most visible in South America. So don't forget to book your tickets! A supermoon that is also the second full moon to occur within 1 month is known as a blue supermoon. Such supermoons don't follow a regular schedule and occur every 10 years or so. According to NASA, the next blue supermoons will happen in January and March 2037. 3 years later, in 2040, we'll witness the Parade of Planets, when 5 planets of the solar system, Mercury, Venus, Mars, Jupiter, and Saturn, will line up. Of course, it won't be a perfectly straight line, but it will still be a pretty impressive view. Some planets, like Venus and Jupiter, can be clearly observed even in big cities and with the unaided eye. But during the Parade of Planets, you'll be able to see more, so perhaps it's time to stock up on telescopes. The brightest supermoon of the 21st century will occur in 2052. The thing is, the orbit of our natural satellite isn't perfectly round. The moon follows an elliptical path while traveling around Earth. That's why there are 2 points, the closest to Earth, called the perigee, and the farthest, known as the apogee. On the 6th of December 2052, we'll see a stunning supermoon. Our satellite will be around 356,000 kilometers away from our planet, which is a bit closer than normally. In 2060, we're likely to see a comet called 15P Finley. It will be one of the closest comets to approach our planet in the last 100 years. It will fly by at a distance of around 5 million kilometers. And here's the thing. Every time a comet comes close to the sun, it heats up and starts emitting gases and dust, looking like a little star. Thanks to solar winds, it also gets a beautiful, long tail, and the closer to Earth a comet passes, the brighter it looks in the sky. So, get ready for a breathtaking show. In 2084, something known as an Earth eclipse will occur, becoming one of the most exciting events of the 21st century. Sadly, we won't be able to see this celestial spectacle from Earth. Duh, obviously. But we might be able to admire it from Mars. During this event, the Moon and Earth will pass by the Sun, looking like dark silhouettes. Such an event is known as a planetary transit, something like a solar eclipse, but with other planets instead of the Moon. In 2100, for those of us still here, the North Star will be the closest to the North Celestial Pole. Sailors have been using this famous star for centuries to figure out where North is. But the funniest thing about this is that this star isn't perfectly aligned with the North. The reason is that Earth doesn't have a fixed axis. It rotates in space like a giant spinning top in a process called orbital precession. That's why the North Star doesn't remain in the same place in the sky. It moves slowly but steadily. But on the 24th of March 2100, the polar star will finally appear over the true north of our planet. And after that, it will start moving away again, to return 26,000 years later. So, as you can see, it's going to be a truly rare event. Plus, it'll be like a parting gift from the North Star. Since Earth's axis is constantly moving, in around 2,000 years, the North Star will be replaced by another, Gamma Cepheus. So, the close approach in 2100 will be the nearest it will be to our planet in a long, long time. I hope you've made notes of the most interesting astronomical events of the next 100 years. The coolest thing is that to witness most of them, you don't even need to buy a telescope. They're gonna be visible to the unaided eye. Ooh, look at that!
The Earth might be on the verge of a huge change. Scientists have discovered that every 200 million years, comets start raining down on our planet. This comet shower changes how the Earth looks, reshapes the continents, and increases geological activity everywhere. We are in the 20th cycle, which means new transformations are coming soon. Why does Earth have active plate tectonics and continents, unlike any other planet? To learn the truth, geologists decided to check out zircon crystals. We often find these tiny crystals in rock. They're very tough and can survive crazy geological processes that could destroy most other minerals. But they're cool because we can use them to learn how old their rocks are. These crystals have some uranium in them, and it decays into lead over time. By measuring how much uranium decayed in a crystal and how much is left, you can figure out the age of a mineral. So, we can use this trick to learn a lot about the Earth's crust and history. Recently, geologists checked out zircon crystals from two of the Earth's oldest continents and regions, the North American Craton in Greenland and the Pilbara Craton in Western Australia. It turned out that rocks from these continents could tell us what happened to our planet during the Archean Eon, from 2.8 to 3.8 billion years ago. It was a crazy era for our planet, back when magma, rich in elements we've never seen before, pierced the surface and broke out for the first time. This event changed what the land looked like forever. And when scientists studied them, they noticed something else. It looks like there's a cycle where every 200 million years, the Earth starts forming new continental crust for some reason. When they explored this further, they suddenly realized that this might be because of our galaxy. Our solar system is located in the Milky Way galaxy, right here in the Orion Arm. An arm is a place that has tons of stars, gas, and dust. There are many of them in the Milky Way, bigger and smaller ones, and they extend and wind outward, making galaxies look like spirals. We're located in a minor arm, about 27,000 light-years away from the heart of the Milky Way, a horrifying black hole called Sagittarius A star. But our solar system doesn't just stay in one place. It moves at a breakneck speed of 150 miles per second. That's like crossing the Earth 22 times in an hour. Just like planets move around the sun, the solar system rotates around the center of our galaxy. This orbital period is called one galactic year. Objects that are closer to Sagittarius A star move faster. You know, your typical inner lane advantage. But large arms, the ones that are further away from us, are much slower. They move at a speed of about 130 miles per second. That's just some 19 runs around the equator in an hour. Because of this difference, the solar system moves kinda in and out of the galaxy's spiral arms. This is like when fans make a wave in a stadium. This leaves a mark on both the solar system and our planet. There is a vast, distant region around our solar system called the Oort cloud. It's about 4.6 trillion miles away from the Sun, like traveling to the Sun and back 50,000 times. Now, the Oort cloud is filled with comets. You might not know this, but they're way more dangerous to us than regular asteroids. Asteroids come in different sizes and are usually just rocks with some metals. They don't have a glowing gas around them. They just vibe around the Sun in their main asteroid belt, somewhere between Mars and Jupiter. And if the almighty Jupiter with its crazy gravity doesn't stop them, sometimes they come down on us, causing some havoc here and there. But a comet is a small object made mostly of ice and rock. When it gets close to the Sun, it heats up and releases dust and gas. This forms a glowing cloud around it called a coma. This is what we see as a tail as the comet moves, and their consequences are much more extreme. When we complete one galactic year, the icy objects from the Oort cloud are pushed towards all our planets. And when we enter the big spiral arms of our galaxy, the rainstorm begins. Comets are much faster than asteroids. When they hit Earth, they leave huge impacts and leave giant craters. The energy from these impacts can melt huge parts of Earth's crust and mantle. The molten rock then rises to the surface, floating there. As it cools, it solidifies and forms a new crust. Over time, these small pieces of crust can merge and grow larger as more solidified magma attaches to them. Eventually, all this forms big continents. So, once in a galactic year, when comets start hitting Earth more often, they really change the Earth's structure and help create new land masses. Another proof of this is spheroidal beds. This is what we call tiny round particles created by material thrown out during impacts. When we look at them, they also match the cycle timing. Spheroidal beds on our planets formed exactly when the Earth was crossing the Milky Way's spiral arms, and most of them formed when it was just over 1 billion years old. There are many cycles that influence our planet. For example, the Milankovitch cycles. the ones that tell us how the Earth's orbit and tilt change over time. This affects the planet's climate, but this new 200 million year cycle is a whole new level. We used to believe that continents only formed because of things that happened deep within our planet. And, well, maybe asteroids influence it a little. But now it seems like the continents were born and shaped thanks to the Milky Way itself. Scientists now want to study these ancient deposits to see if it's actually true. If it is, it could mean that we're getting closer to some huge geological activity. The continents might start reshaping again, or even coming together to form a new supercontinent. The continents on our planet look like puzzle pieces that fit very well, like South America and Africa. And that's not a coincidence. Many years ago, they formed one supercontinent called Pangaea. Pangaea used to be a landmass full of unique creatures, like the giraffe-necked Tanystropheus, the toothless Lystrosaurus, and the reptile bird Drepanosaurus. But the ground beneath us is always moving, floating on magma like vegetables flowing on a super hot soup. And eventually, Pangaea broke apart. However, it wasn't the only supercontinent in our history. This coming together and then breaking apart happens pretty regularly, like with some toxic people. Usually it happens every 200 to 600 million years. So yes, all our current continents will come together again one day. We call it Pangaea Proxima, Pangaea Ultima, or simply Amasya. It could form during the next galactic year. There are many theories about how it might happen. Africa might merge with Europe, and Australia might move north towards Asia. Life on Pangaea 2.0 would be challenging. People would likely have dark skin, hair, and eyes. We would all hang out near the equator and along the coasts because the weather would be nicer and calmer there. The center would be horrifying, hot and dry, filled with deserts. There would be a common language and shared traditions. In general, such an event would really bring us closer together. No pun intended. However, it would also mean that if someone starts fighting, we're all screwed. Also, all the potential health issues might influence everyone on the continent. And let's pray that there won't be any large asteroids this time, or we're definitely doomed. This, of course, the movement of the Earth's crust will lead to a lot of cataclysms. But maybe humans won't even live on Earth by that time.
You know what? 8 out of 10 people worldwide can't see the Milky Way anymore. And in just 100 years, it might turn into a forgotten tale from the past. It's not that the galaxy is disappearing, but that the cosmos is fading from view. Back in our grandparents' day, they could look up and see this vibrant tapestry of stars. But nowadays, we're lucky if we can even count them on one hand. This has nothing to do with nature. It's all because of the creeping threat of something called light pollution. Next time you walk around a big city after dark, take a moment to notice the large number of street lights, neon billboards, and office buildings shining all night long. Those endless city lights create an artificial brightness that competes with the natural glow of the stars. This is light pollution, and it's getting worse. Every year, Earth gets 10% brighter. That means if someone is born today in an area where you can typically see around 250 stars, when they reach 18, they'll only be able to see about 100 of them. Unfortunately, that's already a problem in big cities, where looking up at the stars is becoming something that you can only do in planetariums. It's gotten to a point where, during an earthquake that knocked out the power in Los Angeles in the 90s, many residents called emergency centers to report a massive silvery cloud in the night sky. But what they were actually seeing, perhaps for the first time, was the Milky Way. When you look at Earth from space, you can see vast areas of North America, Europe, the Middle East, and Asia all lit up. Singapore, Qatar, and Kuwait are some of the most light-polluted countries. On the flip side, remote places like Siberia, the Sahara, and the Amazon rainforest are in total darkness. Light pollution shows up in many forms. First, there is glare, like when you're driving and those bright lights literally make your eyes hurt, leaving you very uncomfortable. Then there is clutter, like Times Square with its crazy mishmash of different bright lights all over the place. Light trespass is when light sneaks into places it shouldn't, like a streetlight shining right into your bedroom. And finally, there is over-illumination, which is just using way too much artificial light for no good reason, like keeping all the office lights on throughout the night when no one is even there. All these forms of light pollution aren't just stealing the beauty of the night sky, they're also interfering with astronomical studies. When we rely too heavily on artificial lights, it messes up the work of Earth-based telescopes. And when that equipment can't do their job properly, we end up needing even more expensive space telescopes like Hubble and James Webb. And let's face it, that costs us billions. Turning night into day actually affects all of us, not just astronomers. Nighttime light messes with our sleep schedule and our body's internal clock. This clock keeps things like brain activity, hormone levels, and cell functions on track. So when it's disrupted, it can lead to serious issues like depression, insomnia, heart problems, or worse. One key process that gets messed up is the production of melatonin, a hormone that kicks in when it's dark. Too much light at night lowers melatonin levels, leading to stress, anxiety, headaches, and sleep deprivation. Blue light is the main villain here. You might think that turning on night mode and getting that orange glow in your phone screen is enough, but it's not. Blue light is also present in LED bulbs, the kind we use at home and in city lighting, because they're cheap and energy efficient. My point is that blue light is basically everywhere, and it's a real challenge to avoid it completely. This is also a big part of why we're not entirely sure how bad light pollution is nowadays. I mean, some statistics suggest that this issue increased by 49% over 25 years, up to 2017. But the real figure may be even higher. The thing is, blue light has shorter wavelengths, and the satellites we depend on today struggle to detect it accurately, meaning they don't quite capture the full extent of the light pollution caused by LED lights. Animals are lost and confused too. Their sleep patterns are also affected. A study from Germany revealed that blackbirds in urban areas are getting active much earlier than those in natural habitats. They wake up and start singing up to 5 hours sooner than their country cousins. Migration behaviors are messed up, especially for birds like sparrows and thrushes who travel at night. You see, they rely on the moon and stars as their internal GPS. So you can imagine how disoriented they get when they spot something like Las Vegas's massive sphere, lit up by 1.2 million LED bulbs. The intense brightness hides stars and disrupts their navigation across thousands of miles and continents. And it's not just that. Artificial lighting is unfortunately causing more birds to crash into skyscrapers and high-rise buildings. Insects, like mosquitoes, are also affected by light pollution. Yep, they're kind of gross, so it might not bug you if they're attracted to artificial lights and meet their fate. But remember, they're a crucial food source for many animals, like bats or frogs, so disrupting their populations could throw off entire food chains. Nighttime lights are causing problems underwater as well. Marine creatures near brightly lit panels off the Welsh coast are changing their behaviors, and fewer sea squirts and sea bristles are hanging out near those lights. Another example involves sea turtles. They typically lay their eggs on beaches and often return to the same spots for years. But when those beaches are too bright at night, female turtles might become confused and decide not to lay their eggs there. Now, do we really need all this light? It's hard to say. Some people might feel safer at night, while others think the opposite. You see, it's usually the glare that messes up our sight. Here's an example. If there's a super bright lamp blocking our view, say at a gate, we can't see anything but the light. But check this out. If we partially cover the light with our hands, suddenly we can spot an intruder. Wow. What I mean is that more lamps don't always mean more safety. It's all about using them the right way, and doing things like dimming lights can actually enhance security. Plus, it could save you some cash. Speaking of which, light waste has a pretty big impact on the economy. Take a Cobra Head streetlight, for instance. The light projected directly by it is only 30% of the total light it emits. In the US alone, roughly 1/3 of the light at night goes to waste, and that adds up to a staggering annual cost of $2.2 billion. Electric lights aren't all bad, of course. They have done some good stuff for us, like making our days longer so we can get more done and have some fun after work. But we can totally minimize this issue. Turning off all the lights would be awesome, but let's be real, that is very difficult, if not impossible these days. So, what can we do? Get those fancy controls like dimmers, timers, and motion sensors to make sure our lights are super efficient. Go for warmer colored lamps instead of those harsh blue ones. Oh, and consider using fully shielded light fixtures, like those cool vintage table lamps. They direct the light down where you need it, so you don't get that annoying glare or light scattering everywhere. Plus, when you cut down on wasted light, you're not just helping out the planet, you're also saving some cash on your electric bill. Talk about a win-win.
So get this. Taylor Swift takes a flight from Los Angeles to Tokyo that leaves at 10 a.m. on February 20th. She's on the plane for 12 hours, but she lands only at 2 p.m. the next day in Tokyo. That's a 28-hour difference. So how did this time warp happen? Well, it's all because of this wonky line. This is the International Date Line. You know, that imaginary line that slices the globe in half and decides who gets to celebrate the new year first. It's the Line Islands, by the way. But crossing this line doesn't just make you feel like you've stepped into a transporter. It actually changes your day. Cross from east to west, and boom! It's 24 hours later. If you travel in the opposite direction, crossing the line from the western side to the eastern side, you go back an entire calendar day. Now, you'd think the International Date Line would be a nice, neat, straight line in the ocean where the time zones switch. But in reality, it's as if someone took a ruler and said, let's make this complicated. The line zigzags all over the place, wrapping around islands and causing all sorts of head-scratching confusion. For instance, Big Diomede Island and Little Diomede Island are only 4 kilometers apart, but have a 21-hour time difference. And things can get a little more complicated depending on which time zone a country follows. For example, if you travel 1061 kilometers across the date line from Baker Island to Tokelau, you must add 25 hours. In other words, that's 1 day and 1 hour. And if that doesn't sound weird enough for you, wait, it gets crazier. When it's 6 o'clock in the morning on Thursday in New York, it's still Wednesday night in American Samoa. Meanwhile, over in Kiribati, it is already Friday. Yep, we are talking about 3 different calendar days happening at the same time because of this one imaginary crazy line. This phenomenon occurs every day between 10 o'clock and 10:59 in the morning. So, why does the International Date Line look so ridiculous in the first place? Great question. Although these zigzags may seem completely arbitrary, they actually have a logical basis. It's pretty much a made-up concept based on the Earth's rotation. The Earth is always spinning, and it takes about 24 hours or a day to complete one full rotation. To keep things in sync, people took the Earth and divided it into 24 time zones, each 15 degrees apart. But what is the starting point for a day on Earth? Basically, people needed to figure out which of these 24 zones, or lines, would be the starting line or chronocenter. They needed a reference point, a line where they could begin adding or subtracting time as you move east or west. That line is what we now call the prime meridian. But here's the catch. Deciding where to put this starting line, the prime meridian, is totally arbitrary. The idea of establishing a line where days begin and end goes all the way back to at least the 1300s. Back then, map makers were doing their own thing, picking their own east-west dividing lines, called meridians, which, by the way, is just a fancy Latin word for midday. Without a universal standard for when a day officially started or ended, sailors on long voyages had to just wing it, figuring out how to handle the time they were gaining or losing along the way. So, in 1884, people decided to organize this whole mess. 25 nations gathered at the prestigious International Meridian Conference in the United States, with one big goal: to decide on a line that would serve as the official prime meridian. Finally. Like it or not, they were determined to create the international date line that the whole world would accept and follow from that point onward. The prime meridian was established in Greenwich, England, and the international date line was placed on the opposite side, running through the 180th meridian. Sounds simple, right? But that's when the nightmare really began. The chosen international date line didn't just wander through uninhabited areas. Oh no, it split some countries in half and created all sorts of chaos. I mean, if you divide the world with a completely straight vertical line, you end up with situations where half of a country is 1 day ahead and the other half is 1 day behind. Take Kiribati, Kir-u-Bas, for example. The country is primarily centered in the Gilbert Islands, which sit just west of the international date line. However, in 1979, their territory got a little bigger with the Phoenix and Line Islands, which are way east of the date line. Suddenly, Kiribati was straddling the international date line. This created a bit of a headache for businesses. Folks on either side could only communicate by radio or phone for 4 weekdays a week. To fix this quirky situation, Kiribati decided to skip Saturday, December 31st, 1994, right off the calendar. So, Friday, December 30th, turned into Sunday, January 1st, 1995. And just like that, New Year's came a day early. Woohoo! After that, the date line moved eastward to go around the entire country. The same thing that happened to Kiribati happened to other countries as well. For example, when they got to the Aleutian Islands in Alaska, the line made another detour to include them. And when they got south of the equator, guess what? Another eastward bend to cover even more islands. And that's pretty much why the straight line started to get a bit zigzaggy. This wonky line is designed to avoid land as much as possible, so there's less hassle when it comes to changing days. So, no, you can't stand between the international date line, like having one foot in one day and the other in the next. But you can cross it by boat. In fact, some fancy trans-Pacific cruises even offer a time travel package for adventurous travelers who want to cross the line and jump into the future. In the end, the international date line looks this ridiculous because it was constructed based on a series of arbitrary decisions, historical quirks, and a whole lot of confusion. But it's not just because people organized it in the 19th century that there is no confusion regarding time zones today. Another thing that the prime meridian establishes is Coordinated Universal Time, the famous UTC. UTC never changes for daylight saving time or anything else. However, in 1908, Canada decided to spice things up by creating Daylight Saving Time, or DST. Their idea was to set the clocks 1 hour ahead of standard time to make better use of sunlight in the spring, summer, and fall evenings. The idea was so brilliant that most countries jumped on board. But not everyone. Just look at Nepal. They have never, ever used the daylight saving time, which means their clocks do not change throughout the entire year. As you probably know, countries with large territories often have more than one time zones. Just like the United States, which has 11 time zones. Australia has 9, while India is a special case. Look, India is a big country with an area that stretches around 3,000 kilometers from west to east. So, it should have 3 time zones in total, but they have only 1. This means that the sun rises almost 90 minutes earlier in Dong in the far east than in Gujar Motay in the west. And why do they only have 1 time zone? Well, basically because they can. Just remember that the international dateline and time zones are invisible, artificial, and, now you know, totally arbitrary. So if a country wants to stick with just 1 time zone to simplify processes and business operations within its borders, then hey, why not?
In April 2023, astronomers found something exciting: a runaway black hole. This thing is moving through the universe at an incredible speed, about 3.5 million miles per hour. It's 4.5 thousand times faster than the speed of sound. They found it accidentally. Researchers noticed that there was some weird straight line in Hubble images. After some digging, they realized there was a moving black hole. As it moves, it compresses the gas on its path, literally creating new stars along its journey. So it's leaving a beautiful, long trail of stars behind it. And when I say long, I mean it. Its tail is 200,000 light years long, which is like the length of 2 Milky Ways. Turns out one end of this star trail connects to a distant small galaxy. This is probably where the black hole came from. Most likely there were 2 supermassive black holes whirling around each other. And then another galaxy came along with its own supermassive black hole and ejected one of the original ones like a mean kid, which is why it's called Runaway. There might be a 9th planet with the very original name Planet 9 in our solar system. If it exists, it's probably somewhere far beyond Pluto. Astronomers think so because some rocky objects near Neptune move in a weird way as if they were influenced by the gravity of a large, unseen planet. Planet 9 might be a gas or ice giant 7 times the mass of Earth. One of the ideas is that it could have existed in our solar system, but then bumped into something huge and ended up with a crazy long orbit around our sun. If we actually discover it, it could change our understanding of the solar system. A new telescope is coming soon, equipped with the largest digital camera ever built, and it will start scanning the sky in 2025. Maybe it will finally spot this mysterious planet. Another awesome discovery was made in 2023. The James Webb Space Telescope found over 500 planet-like objects in the Orion Nebula. Some of them are roughly the mass of Jupiter, so they're literally called Jupiter mass binary objects, or jumbos. They just float out there with no stars, and they're not really stars or planets themselves. What's even crazier is that in about 42 pairs of them, the objects are orbiting each other, even though planets aren't supposed to do that. On top of that, such large objects shouldn't form and exist without a star at all. So now, astronomers are trying to explain this. Perhaps jumbos have formed in places where there was enough stuff for big planet-like objects, but not enough for stars? Or maybe all of them were ejected from their star systems for some reason. Who knows? But now we definitely need to study them. The black hole in the center of our galaxy, Sagittarius A star, used to be super weird. Luckily, it didn't run away like that other one, but it was completely crazy in the past. Astronomers found 2 supermassive structures called the Fermi bubbles and eROSITA bubbles. They spanned about half the width of our entire galaxy, and they've been towering over the Milky Way for over 2 million years now. And scientists think that it's our black hole that created them. It seems like when it was at its peak activity, it had a wild, energetic eruption that lasted about 100,000 years. This event probably left these bubbles. In 2023, the James Webb Space Telescope took a striking, super detailed image of the so-called Herbig-Haro objects. These objects are called Herbig-Haro 46/47. They're basically young stars surrounded by beautiful patches of nebulosity. You can see the stars being surrounded by a disk of material that feeds them as they grow for millions of years. They're located at about 1,470 light-years away, but they're actually not our main topic of discussion. What's much more interesting is this weird thing right below them, a space structure that looks like a question mark. What is this thing? No one knows for sure. It has an orange-red color, which hints that it might be super distant, far from our galaxy, maybe even billions of light-years away. Some think that this strange question mark is probably the result of 2 or more galaxies merging together. One of them was a bit curved, so it's probably a distorted spiral galaxy. The curve might be the tails being stripped off as they spiral towards each other. The other one was rounder and smaller, like a regular spherical one. The gravity games never fail to amaze us. Astronomers started searching for extraterrestrial megastructures. They think that if there's another intelligent civilization out there, they could have built something incredibly huge to power their technology. For example, like Dyson spheres. Hypothetical structures around stars that use the star's energy as fuel. Astronomers analyzed some historical telescope data that detects infrared signals. They spotted some weird signals that could hint at the presence of these structures. In total, there are 7 such candidates right now. All of them are coming from red dwarf stars, which are redder, smaller, and less massive than the Sun. Another research institute found 53 potential candidates. They're still not sure what exactly causes these signals, but it could be not Dyson spheres, but some huge debris. It looks like there are some mysterious structures in the center of our galaxy. In 2023, the James Webb Space Telescope has taken a detailed picture of the Sagittarius C region. It's right near the center of the Milky Way. This image showed a dense area where stars are forming. There were many young stars and dark clouds that blocked the light from the stars behind them. That's a very packed place, with about 500,000 stars of different ages, sizes, and colors. This place is very chaotic and extreme. Now, scientists are using it to study star formation. But the weird part is that they noticed something else: the large region of ionized hydrogen. It looks like cyan in the image. This area is about 25 light-years long, surrounding the lower side of dense cloud. And it looks like there are some needle-like structures. They seem to be located randomly, and astronomers have no idea what they are. So now they have to study this in more detail. Astronomers have found a super rare massive galaxy. It's called JWST 7329, and it's absolutely ancient. Our entire universe is about 13.8 billion years old, but the stars in this galaxy seem to have formed around 13 billion years ago, so just around 800 million years after the Big Bang. Also, this venerable elder has 4 times more mass in stars than our Milky Way does today. This strange discovery challenges what we know about galaxy formation and the nature of dark matter. Everything we know tells us that galaxies shouldn't have formed so early. There shouldn't have been enough dark matter for that, but here we are. So, perhaps our models need some revision. There was an incredible astronomical event called AT 2021 LWX, which is also called Scary Barbie. It was an unbelievably bright burst of energy that happened on April 13, 2021. It's one of the most energetic space events ever observed. No galaxies or quasars were nearby, so what in the world happened? At first, astronomers thought that it was caused by a supermassive black hole pulling in a massive star. But after some studying, they think it's probably because a giant black hole had some crazy dinner. It probably ate a large amount of gas, possibly a giant molecular cloud. The titanic black hole in question is between 100 million and 1 billion times the mass of the Sun. This is one of the most massive known and active black holes. Astronomers found the oldest strand of the cosmic web ever seen. The cosmic web is what we call a huge structure of the universe that's made of interconnected filaments of galaxies and dark matter. They're like a framework for galaxies and other structures, playing a crucial role in their formation. The filament we're talking about is made up of 10 closely packed galaxies. It's unimaginably huge, stretching over 3 million light-years. And it looks like the newly discovered strand is very ancient. It occurred only 830 million years after the Big Bang. It's probably anchored by a luminous quasar. This discovery makes us question how exactly galaxies are formed and what exactly happened to our universe after the Big Bang.
The James Webb Space Telescope is an absolutely stunning piece of equipment, which is around 100 times more powerful than the Hubble Space Telescope. And the latter has managed to observe places that are around 13 billion light-years away. But recently, James Webb has outdone itself. It spotted something it wasn't supposed to see. Astronomers using the telescope have detected a supermassive black hole from when our universe was less than 600 million years old. Just a baby. This discovery is the most distant, actively feeding supermassive black ever observed. It's located at the heart of its host galaxy, designated Sears 1019. The black hole is also one of the smallest and least massive ones found in the early universe. It's equal to approximately 9 million suns. It might seem like a lot, but in reality, Supermassive black holes often grow to billions of times the mass of our star. But what is so unusual about this find, and why are scientists having a hard time trying to explain it? You see, it's supposed to take way longer than 600 million years for a supermassive black hole to grow to its full potential. It happens when a black hole either feasts on surrounding matter or merges with a larger black hole. Even black holes similar to the one at the center of our Milky Way galaxy, which is almost 4.5 million times the mass of our Sun, are supposed to be seen in the more recent universe. Well, to tell you the truth, scientists have long suspected that supermassive black holes could have existed in the early universe. But this theory has been proven only thanks to the JWST and its infrared eye. It has shown that the black hole Sears 1019 is actively munching on all the matter it can lay its hands on. Such feeding black holes are usually surrounded by swirls of gas and dust falling inside them. Such swirls are also called accretion disks. The gravitational force of a black hole heats this matter, which makes the disk shine bright like a diamond. Sorry, but that's not all. Strong magnetic fields produced in the process channel the matter to the poles of the black hole, and from time to time this matter is blasted out of there in twin powerful jets. They move at a speed that is close to the speed of light, which generates incredibly bright light. By the way, astronomers were watching the galaxy hosting the unusually old black hole as part of the Cosmic Evolution Early Release Synth survey. They saw the galaxy as it was when the universe, which is around 13.8 billion years old now, was a mere 570 million years old. Besides the main character of this video, scientists spotted two other black holes. Those probably appeared 1 in 1.1 billion years after the Big Bang, and 11 ancient galaxies that existed between 470 and 675 million years after the beginning of cosmic history. The coolest thing about all these discoveries is that until recently, all research about things that existed in the early universe was mostly theoretical. But now, with the help of the James Webb Telescope, astronomers can not only see galaxies and black holes at unimaginable distances, but they can also measure them. This isn't the only discovery connected with black holes made recently. For example, not so long ago, scientists saw two stars slow down in their orbits around black holes and concluded it was most likely the result of drag produced by dark matter. It was the first time astronomers might have discovered some indirect evidence that huge amounts of dark matter could surround black holes. Now, about that dark matter. What is it, and what does it consist of? Our universe consists of normal matter, and dark energy. Normal matter, which is everything you can see with your own eyes or with the help of instruments, makes up around 5% of the universe. Since it's such a small fraction of the universe, maybe we shouldn't call it normal? Dark energy takes up around 68%, and about 27% of the universe is dark matter. This dark matter is just one more space thing that confuses scientists to no end. If dark energy is a force responsible for the expansion of the universe, dark matter is supposed to explain how objects work together. Potential candidates for dark matter vary from strange particles to super-dim objects. But even though astronomers can't grasp what exactly dark matter is, they know for sure what it isn't. This matter is dark, so we can rule out visible stars and planets. It also can't be dark clouds of normal matter. Otherwise, scientists would be able to detect it. Dark matter is not antimatter, since astronomers don't see unique gamma rays that appear when antimatter comes in contact with matter. And neither is dark matter gigantic galaxy-sized black holes. In other words, dark matter is still as much of a mystery to us as dark energy. Anyway, back to the potential dark matter discovered around the black holes. If it is confirmed, it'll be a great breakthrough in dark matter research. What helped scientists come up with this idea is that dark matter interacts gravitationally, influencing ordinary matter. So, a team of researchers watched the orbits of two stars decay by about 1 millisecond per year, while they were circling their companion black holes. The scientists concluded that these changes in speed were the result of dark matter generating friction and a drag on the stars. With the help of computer simulations of the black hole systems, the team tested a model widely known in cosmology. It's called the Dark Matter Dynamic Friction Model, and it predicts a certain loss of momentum by objects that are gravitationally interacting with dark matter. And guess what? The simulation matched these predictions. The results of this research helped to confirm a theory that had existed for a long time, that black holes can actually swallow dark matter that comes too close. As a result, dark matter gets redistributed around black holes, creating areas with different densities, which can influence the orbits of surrounding objects, like the stars we've been talking about. Speaking of black holes, there's a theory that primordial black holes could actually be dark matter. This type of black hole is hypothetical since scientists have never got any real proof of their existence. Such holes are insanely old and quite tiny. By black hole standards, that is. Astronomers believe they could appear several milliseconds after the Big Bang. At that time, stars and galaxies weren't born yet. It means primordial black holes probably witnessed the entire history of the universe. By now, the smallest primordial black holes have most likely evaporated away, but some bigger ones can still be scattered out there in space. If primordial black holes indeed existed, they could appear because in some regions of space, it was hotter, other regions were cooler, and some areas were extremely dense. Scientists believe these dense spots could collapse into primordial black holes. The most curious thing, though, these holes might be so small exactly because they popped up right after the Big Bang. The thing is, the longer it took a black hole to appear, the larger it was. The mass difference between older, smaller, and younger, bigger black holes was incredible. Compare the mass 1,000 times greater than our sun's and that of a pea. There you go. Anyway, the idea of the connection between primordial black holes and dark matter, or rather, the idea of them being the same thing, remained unpopular for decades. But recently, scientists have realized there are many more black holes in the universe than they used to think, and it means that the theory might actually work. And the vast and still hidden from us population of Big Bang black holes could not only make up but be dark matter. After all, astronomers haven't discovered a single dark matter particle yet, even after decades of searching.
Dark matter is a mysterious substance that makes up about 85% of the total matter in the universe, yet we can't see or touch it. The regular matter that we're used to forms stars, planets, and everything around us. But dark matter doesn't emit, absorb, or reflect light, which is why we can't even see it. We don't even know if it actually exists. The reason why we believe in dark matter is because it leaves gravitational effects on galaxies and other cosmic objects. For example, spiral galaxies spin in a way that doesn't match the laws of physics we know. According to our current knowledge, the outer edges of these galaxies should slow down, but they don't. They either keep the same speed or even speed up. It also seems to be acting like an invisible glue that holds galaxies together. If dark matter didn't add some invisible gravitational mass, the galaxies would literally break apart, not being able to hold stars together. But even though it's fundamentally important for our world, we still don't know exactly what dark matter is made of. This has been going for years. Some experiments saw hints of it, but no one's been able to prove it beyond a doubt. Maybe the future Circular Collider will be able to find it. There's a mysterious force in space that seems to be pulling our entire galaxy, along with many others, toward it. This force is known as the Great Attractor. Wink wink. It's a crazy massive region in space, about 10 million billion times the mass of our sun, with a super powerful gravitational pull. Scientists think it might be a supercluster of galaxies, but they're not sure. The problem is that we can't see it directly because it's hidden behind the Milky Way, while the Milky Way itself, horrifyingly, is moving toward it at a speed of about 595 kilometers per second. Just like with dark matter, we only know it's there because of how it affects the movement of galaxies around it. These galaxies are being pulled towards this region, even though, since the universe is expanding, they should be moving apart from each other. What's even weirder is that this great attractor might itself be moving towards something even bigger, the Shapley supercluster. It's the largest concentration of galaxies in our nearby universe. In 2017, astronomers discovered a strange object called Oumuamua. This was the first known visitor from another star system. The thing was quite small, from about 100 meters to about 1 kilometer long. It was also long and thin, had a reddish color, and moved in a very unusual way. As it passed the sun, it unexpectedly sped up and then left our solar system just like that. Tons of theories started sparking up. It was too weird looking for an asteroid. Scientists thought it might be a comet, but it didn't have the usual traits of one, like a tail of gas and dust. Eventually, some scientists even started to suggest the wildest theories, like it might be an extraterrestrial probe. People have been making a huge fuss about Oumuamua since then. But after a while, it turned out that it was just a natural object with unique properties. It was probably a fragment from a distant star system, like a piece of a disintegrated comet or even a chunk of a planet. But Oumuamua caught everyone's attention so much that in 2022, astronomers even proposed to send a spacecraft to catch up with it. This mission could take about 26 years. Now, as for extraterrestrial creatures, where is everyone?
There's this thing called the rare Earth hypothesis
that suggests that life as we know it is actually super rare in space. In the 70s and 80s, scientists argued that Earth is just an ordinary planet in an ordinary solar system. If we look at it this way, life should be widespread across the universe. It seems unreasonable to think that, with trillions of planets, there will be no planet like ours anywhere. But then, a geologist, Peter Ward, argued that the development of complex life like ours depends on a very rare combination of things. The history of the planet, with all its astrophysical and geological conditions, should line up perfectly for complex life to develop. Just think about it. Being in the right zone of the galaxy, on a good distance around the stable star, a rocky planet with water and right atmosphere, emergence of molecules, monkeys deciding to walk, and so on. This would also explain the Fermi paradox, which asks, if extraterrestrial life is common, why haven't we seen any signs of it? Well, the rare Earth hypothesis explains it. The universe might be full of plants, extraterrestrial critters, and fun animals. But would there be an intelligent species like humans? That's another story. As for humans being intelligent, that's another matter, dark matter. And even if they do exist, we could be incredibly far away from each other. This would make communication or contact with other intelligent species very unlikely. There's another similar theory called the Great Filter. This idea says that there might be a big obstacle somewhere along the path from microbes to advanced civilizations. It was the idea of the economist Robin Hanson. He also believed that maybe intelligent life, as we know it, isn't that common in the universe. Although he assumed that it's not because our planet was a result of tons of unique conditions, but because there must be some sort of filter that reduces the chances of life progressing to our point. Who knows where this filter is? It might be in the stage of early microbes, which means that we managed to get through it, or somewhere ahead in the future, which means we might go extinct like many species before us. Maybe the next stages, such as colonizing other planets and the galaxy, are much harder, if not impossible. Something unexpected might come up. Potential catastrophes, resource exhaustion, or other challenges. There's this thing called a pulsar. It's a weird type of star that sends out regular bursts of radio waves, like a flickering space lighthouse. In space, you can often find a pulsar and a smaller companion star that rotates around it. But one day, scientists discovered this system which was also surrounded by tons of some energetic material. They suddenly realized that these are probably the remains of another companion star, which was very big in size, but the pulsar was blasting out powerful radiation and particles, slowly consuming its companion. This is kinda like how a black widow spider eats its mate, hence the name. Since then, they've found other similar systems. They've grouped them all into one spider family. There are also redback pulsars, which destroy slightly larger companions, and huntsman pulsars, which have companions that are massive enough to resist being completely destroyed. We found a water cloud in space, around a black hole.
It's a gigantic water reservoir that's located about 12 billion light years away from Earth. This must be the largest and farthest water reservoir ever detected in the universe. This one cloud contains an astonishing 140 trillion times more water than all of Earth's oceans combined. That's wet. The water surrounds a quasar, which is basically an incredibly energetic supermassive black hole. This quasar is about 20 billion times larger than the sun and emits as much energy as 1,000 trillion suns. You do the math. As the black hole slowly consumes everything around it, it releases energy. This energy heats the surrounding gases and dust, causing the formation of water vapor. As a result, the black hole is surrounded by a huge water cloud, and all the other gases and dust bath around it. This pair formed when the universe was only 1.6 billion years old, just a fraction of its current age. That means that water isn't young at all, and has been existing in galaxies for billions of years now. This quasar will only keep getting scarier and bigger. If it eats up all this gas and dust around, it could grow up to 6 times its current size, potentially becoming 120 billion times larger than the sun. Think about that. Usually, when we look at the photos of astronauts in space, we can see that they're sorta attached to the spacecraft. But there was one brave astronaut who took a wild step into the great unknown without any safety line connecting him to the shuttle. This brave man was Bruce McCandless, and he did that stunt back in 1984. How did he come back, you may ask? He did this cool trick using a nitrogen jetpack, which NASA called the Manned Maneuvering Unit. At first, he tried out some test maneuvers in the Challenger's payload bay. And only after he made sure it was all right did McCandless decide to go for it and glide a staggering 100 meters away from the shuttle. A bit of sad stats here. Out of the 430 people who have made the leap into space, 18 have sadly lost their lives, which gives us a fatality rate of just over 4%. With these numbers, it's safe to say that space shuttles are the least safe means of transport out there. Duh. Alright, let's make it a tad brighter. If we crunch the numbers a bit better, we can get a smaller percentage. But how? Well, 4% is a bit misleading because when we count, we take all the space flights. However, some people flew several times, which reduced the probability. With over 600 seats filled across 113 shuttle flights, the true fatality rate for shuttle missions is actually closer to 2%. Let's test your general knowledge now, shall we? So, what was the first living thing ever sent to space? If your answer is a monkey, you aren't right. Those who said dogs. Sorry you guys, but it's not correct either. On the 9th of July, 1946, fruit flies became the first living creatures to make it to space during a suborbital V-2 rocket flight. Then, on the 20th of February 1947, these little guys safely returned from their journey, opening the door for future human space exploration. Before we sent to space mammals, like the rhesus monkey Albert Sacco in 1949 or the famous space dogs, scientists spent a lot of time studying fruit flies to see how they reacted to radiation and the conditions of space travel. Researchers started using fruit flies for experiments back in the 1910s. Guess why? Because we humans share a lot of genes with these yucky pests. Imagine hearing some creepy music all of a sudden when there's nothing but darkness around you and nobody is there to help you. Right now, imagine how elevated this experience was for astronauts who heard some creepy music in their space shuttle. Months before the moon landing, Apollo 10 astronauts were orbiting the moon testing equipment when they heard strange audio noises. Astronaut Eugene Cernan noted the eerie sounds, joking they were like weird music. At that moment, the astronauts didn't have contact with mission control. They were over the moon's dark side. Although the noises resembled something from a sci-fi film, NASA downplayed them as they were focused on the astronauts' mental health. Despite years of speculation, the source of the sounds remains unknown, with theories ranging from radio interference to charged particle activity.
Cernan later remarked that they didn't take it seriously and didn't report it after the mission. Chances are, we've already received messages from new friends from other galaxies, but we just failed to understand them. In August 1977, some astronomers using the Big Ear Radio Telescope at Ohio University picked up a strange narrowband radio signal from the constellation Sagittarius that lasted for 72 seconds. The signal buzzed at a frequency of 1,420 MHz, which is significant because it matches the natural emissions from hydrogen. This frequency had been flagged by scientists almost 2 decades earlier as a likely choice for extraterrestrial civilizations trying to reach out to us. They dubbed it the WOW signal after one of the astronomers wrote WOW on their printout. We've never heard that signal again, and no one has been able to explain its origin satisfactorily. After spending about a month in space, astronauts start losing quite a lot of skin from the bottoms of their feet, especially those tough calluses they've built up over time. One astronaut even called mission control in a bit of a panic when he noticed a chunk of his heel drifting off in zero gravity. But no worries. As the old calluses peel away, new ones spring up on the tops of their feet. They need that grip to hold on to all the restraints, kind of like airborne trapeze artists. Going number 1 and seeing blood is as scary as it sounds, and yes, in the weightlessness of space, blood doesn't settle in the lower body in the same way it does on Earth. This can lead to some alarming situations on board. Natural urges are universal, regardless of location. There are 2 main reasons why astronauts are unable to use traditional toilets in space. First, water is an extremely valuable resource aboard a spacecraft. Second, there's no gravitational flow of water in space. The drinkable water on a space station is contained in pouches and is used accordingly. In a weightless environment, a specialized device with suction and disposable bags is used for waste collection, with the storage being replaced every 10 days. Additionally, spacecraft are equipped with complex systems designed to recycle and filter liquid waste, converting it back into usable water for the astronauts' daily needs. As if that wasn't enough, spending an extended period floating around in space brings another challenge. The body may lose its bursa sacs, those handy little cushions that sit between our hip joints. While this may not pose an immediate issue in the zero-gravity environment, returning to solid ground can turn the simple act of sitting down, whether in a chair or on a toilet, into a real struggle. The fluid shifts that contribute to blood-related issues don't stop there. They can also wreak havoc on astronauts' sinuses, creating a constant feeling of congestion. It feels like living in a stuffy room all the time, where relief seems just out of reach. Thus, the challenges of long-term space travel add up, making the experience as daunting as it is thrilling. Another challenge astronauts run into is vision loss, also known as ocular syndrome, which sounds all science-y. While the exact cause is still a bit of a mystery, it's thought that extra pressure on the brain can mess with both the retinas and optic nerves. And here's a fun fact, it mostly affects guys. By the way, you might assume that shutting your eyes in space means it's pitch black, but that's not the case. Because of high levels of radiation, astronauts can still see bright lights when they zip through certain parts of their orbit. It's a pretty strange phenomenon that keeps them on their toes, even with their eyes closed. 12. Switching gears, let's talk about bone health in space. It turns out that being weightless can really take a toll on astronauts' bones. Like, they can lose up to 2% of their bone mass every month, which is pretty wild. But the good news? They've come up with new exercise routines that help fight off that bone loss. So, while space travel definitely has its challenges, researchers are working hard to keep astronauts in tip-top shape as they explore the universe. The Big Crunch is a cool theory about how the universe might end, and it's basically the opposite of the Big Bang. So imagine the universe expanding for ages, but then it hits the brakes and starts collapsing in on itself.
maybe even forming a huge black hole. Scientists are looking into this by checking out the universe's density. If it's too dense, such a collapse might really happen. At first, people thought that gravity would eventually take over and stop the expansion from the Big Bang. But then we found this mysterious thing called dark energy, which is actually speeding up the universe's expansion. Because of that, it seems like the Big Crunch is pretty unlikely. Right now, the evidence shows that dark energy is here to stay, so the universe will just keep on expanding forever.
Okay, here's the deal. Something is bound to happen that can affect everything we've ever known about space and time. You've heard about black holes, right? That denser-than-life type of phenomenon that usually exists in the center of galaxies? Two of them, located 9 billion light-years away from Earth, are expected to collapse into each other. And my oh my, I do not want to be around to see that. Let's get one thing straight. Black holes are the most powerful things in the entire universe that we know of. If they decided to go all Revenge of the Sith on us, we'd be doomed. A black hole was once a massive star that went supernova, meaning that the star collapsed onto itself, and the sheer magnitude of the explosion created a black hole in its place. Oh, by the way, black holes do not pull things inside like a vacuum cleaner. That's just a popular myth. Say we were to replace our sun with a black hole at the center of the solar system. Not much would change, except that maybe we'd all freeze. Yup. But black holes can do something much worse than vacuum stuff. They can delete the universe itself. If a black hole was to follow a normal timeline, it would go from its creation to total disappearance. But this process is very, very slow. I'm talking about billions and billions of years before a black hole loses its mass entirely. That happens because they're constantly losing their mass every single second. Black holes radiate their mass away, like a boiling teapot loses its water as steam. Yet, things rarely go as planned, both in our lives and apparently in the universe itself. So it wouldn't be that much of a surprise to find out that two black holes are en route to collapse. That's what scientists have found out recently. And let's just say that this is one of the reasons why the scientific community is freaking out just a little bit. The first question that comes to mind is, what does that mean for us humans? Total annihilation? Now, no need to be this dramatic. The best case scenario, we'd be in for an interstellar type of experience. Roll me in, please. Let's rewind a little bit to understand how this would happen. 45 years ago, a group of scientists began noticing a weird behavior coming from a galaxy far, far away. The galaxy is found 9 billion light-years away, and its scientific name is a mouthful, but let's just call it Super Far Away Galaxy. You might be asking yourself, well, how did scientists observe this black hole so far away if it doesn't emit any light? Good question. That's because black holes gather disks of gas around them, and they emit some of this material into space. These jets can be detected from a distance of millions of light-years. Now, if these hot gas jets are directed towards space, then scientists give these black holes a special name, blazars. A particular blazar has been gaining worldwide attention recently. Long name, but let's just call it Andy. Imagine you're a scientist at Caltech and you're looking at a blazar in your radio telescope and you notice its strange behavior. Its brightness goes on and off, like the ticking of a clock. At first, you don't understand what's happening over there in a distant corner of the galaxy. But then, you realize there must be another black hole circling the first one. In other words, scientists discovered that Andy was being orbited by another blazar, Gomer. And the regularity of their twinkling can only mean they are close to a total collapse. It gets worse. Each of the two blazars is estimated to be a few 100 million times the mass of our Sun. Have you seen our Sun? It's huge. It's already 333,000 times the mass of our Earth. This means we're destined to face something out of our league. Now, this is not the first time scientists have detected something like this. In September 2015, the LIGO Observatory detected a collision of two black holes. Each of them was as heavy as 30 suns, and an equivalent of 3 solar masses was released once they crashed into each other. And guess what? This gravitational wave passed through Earth at the speed of light. But we really weren't affected by it. Maybe you were sleeping and felt something weird in the air, but nothing significant happened to us as a species or to our planet. But that's because the blast was weak. The thing is, the expected collision between Andy and Gomer will send unprecedented gravitational waves throughout galaxies, and they will reach the solar system. But what is this shock wave actually capable of doing? Well, it could stop our sun from releasing gas for a few minutes, which means it would stop heating the solar system. So, let's say you were going about your summer day, and out of the blue, the atmosphere froze for a few seconds. Doesn't sound too nice, huh? But that's actually a better possibility than the next one. In one of the worst-case scenarios, a blast from the collision between Andy and Gomer could break bonds between atoms and make everything disintegrate. You, me, your cat, we'd all turn into flying particles floating in the vacuum of space. This may sound scary, but scientists say that an atom is made out of 99% empty space. This means that everyone on this Earth, all 8 billion of us, and everything that exists, planets, objects, animals, are all made up of 99% empty space. So perhaps all that Andy and Gomer would do is separate all of our atoms and desolidify us. Then again, the blast could mess with the fabric of space and time as we know it. You remember Albert Einstein, right? Crazy hair? He's the name behind the theory of relativity. Einstein discovered that time is relative. It's always dependent on the observer. This would mean that time is not the same throughout the cosmos. Why though? Well, because Einstein's theory of relativity is also a theory of gravity. Einstein discovered that gravity is the effect that objects have on the fabric of space-time. Every object that has a mass, including you, me, your cat, and our planet, creates a warp or a distortion in the fabric of space-time that causes it to bend. The bigger the mass, the bigger the gravitational force, and the bigger the distortion on the fabric. It may sound complicated, but hey, this is what creates different perceptions of space and time throughout the cosmos. This is why you'll age differently on Earth and on Jupiter. This is why time passes completely different for astronauts on long missions and for people that remain on Earth. And this is why a collision of two mega blazars could mess with our perceptions of space and time, due to the sheer force of its gravitational shockwaves. Got it? Not to mention that black holes are already a huge warp in the fabric of space-time. You remember that Interstellar scene, right? Where the lead character bends the space-time continuum through a black hole? Now, don't try this at home though. As far as we know, anyone who chooses to go inside a black hole has no guarantee of making it home again. Scientists say that this blazar explosion will happen in approximately 10,000 years. But wait a minute. If this blazar lies 9 billion light-years away from Earth, it means that these two black holes should have already collided long before our solar system and home planet were born. You see, the solar system was born around just 4 billion years ago. And since it takes us 9 billion light-years to receive the light emitted from the blazars in the first place, this means that the collapse of the two blazars already took place, and it'll reach Earth 10,000 years from now. This means the shock waves are already making their way through the galaxies at this very moment. But still, it's not something even your great-great-great-great-great-great-grandchildren will be around to see.
At breakneck speed, this mysterious object is zipping through our galaxy. It's moving at a staggering 1 million miles per hour. That's so fast it might potentially escape the Milky Way altogether. While scientists are trying to understand exactly what this space weirdo is, we're going into space to learn more about it. The object is currently moving at a distance of 400 light-years away from Earth. Let's have a closer look and try to figure out if it could be a runaway probe. Nah, it's way too large for that. The object is around 30,000 times the mass of Earth and 8% of the mass of the Sun. What a giant! Such a size places it in a category that Dr. Darren Baskill, an astronomy lecturer at the University of Sussex, describes as somewhere between a star and a planet. Stars moving at such extreme speeds are super rare. Only 1 or 2 out of every 1,000 local stars travel so incredibly fast. So, if one day you found a star moving as rapidly as our cosmic enigma, you'd see it leave our home Milky Way galaxy in just a few tens of millions of years. In terms of space and cosmic distances, it's a blink of an eye period of time. After all, such stars can live for tens of billions of years. Even though the mysterious object is only moving at 0.001% of the speed of light, it's still potentially fast enough to eventually break free from the gravitational pull of our galaxy and fly into intergalactic space. Let's put this speed into perspective. J1249 is traveling 2.6 times faster than the fastest space probe ever launched. I'm talking about the Parker Solar Probe. The Parker probe reached this speed in June 2024 while looping around the Sun. J1249 was discovered by citizen scientists volunteering for NASA's Backyard World Planet 9 project. These volunteers sift through online images taken by NASA's Wide Field Infrared Explorer and NEOWISE missions. They're looking for anything interesting. 3 of those volunteers spotted a faint, fast-moving object as it moved across WISE images. When they realized what they were looking at, they were incredibly excited, but thought someone had already reported the space object. But surprisingly, that wasn't the case. At the moment, most scientists believe that CWISE J1249 could either be a low-mass star or a brown dwarf. That's a type of star that is larger than a planet but too small to support nuclear fusion in its core, like our Sun does. In other words, such stars don't have enough mass, and their cores can't burn their star fuel, radiating starlight. That's why brown dwarfs, often referred to as failed stars, are smaller and cooler than the Sun. They even have complex planet-like atmospheres, which have clouds and molecules. For example, H2O. Anyway, to confirm or disprove this theory, astronomers continued to observe the object with the help of ground-based telescopes. Soon, they found out that the object had an unusual composition, with much less iron and other metals, compared to typical stars or brown dwarfs. It allowed NASA to claim the unthinkable. J1249 could be one of the oldest stars ever found in our galaxy. Okay, that's certainly a game changer, but why is this potential star moving so fast? The research team has a few theories. For example, the object might be the remains of a binary star system where its companion, a white dwarf, exploded in a supernova after pulling too much material from J1249. Another possibility is that our mysterious traveler may have originated from a cluster of stars that dispersed after coming across 2 black holes. According to experts, one way to get to such extreme speeds is to fall toward an object and miss it. Such gravitational slingshots are how space probes are accelerated to extreme speeds, which allows us to explore the solar system up close over reasonable timescales. The same technique could also explain the speed of J1249. The star could have been born in the crowded center of our galaxy. Then it might have fallen toward a star, missed, and in the process was accelerated to extreme speeds. Well, let's leave astronomers to search for more evidence to confirm this exciting theory. Meanwhile, we're heading further to the binary star system 55 Cancri. It lies 41 light-years away from Earth and hosts an amazing planet, 55 Cancri e, also known as Janssen. This is a scorched super-Earth, 8 times the mass of our planet, and it orbits its star in just over 17 hours. Yep, the year on this planet is shorter than 1 day on Earth. Plus, it's 25 times closer to its star than Mercury is to our Sun. No wonder the planet's surface reaches blistering temperatures of 4,350 degrees Fahrenheit. That's hot enough to melt nearly any known metal. Back in 2010, a study found out that the host star of 55 Cancri e had an unusually high carbon-to-oxygen ratio. If this ratio was also true for the planet, it would mean that 55 Cancri e might have huge quantities of carbon. And the coolest thing? It would be in the form of diamonds. It'd make this space body a literal diamond planet. Sadly, some follow-up studies discovered that the carbon-to-oxygen ratio on the planet was less extreme than originally thought. It makes the idea of a diamond-encrusted world less feasible. On the bright side, planets don't always have to match the composition of their host stars exactly. If some other process topped up the carbon on 55 Cancri E, it could still be the most precious planet known in the universe. Definitely worth a visit. But let's leave the diamond planet behind and fly to Vega, which holds a special place as one of the brightest and most important stars in the sky. The brightest of other stars is measured against the brightness of Vega on a special magnitude scale, where Vega's magnitude is 0. A star with a magnitude of 1 is 2.5 times dimmer than Vega, and a star with a magnitude of -1 is 2.5 times brighter. Vega is also a pole star, although not at the moment. Right now, Earth's axis points toward Polaris, the North Star, but Earth's axial tilt draws a circle over 26,000 years, and Vega will again be the pole star in about 12,000 years. Just you wait. But the coolest thing about Vega, which sets it aside from other stars, is that it's not shaped like a perfect sphere. Unlike the Sun, which rotates slowly and is almost spherical, Vega spins very fast, completing one rotation in just 12.5 hours. And it causes it to bulge at the equator, taking on an egg-shaped appearance. And now, get ready for the most dangerous encounter of them all. But first, I must warn you. Even though space is unimaginably vast, it's populated extremely sparsely. The universe's average density is equivalent to 6 protons in 35 cubic feet. But some areas, known as voids or supervoids, contain even less matter. These regions are enormous and can span 30 to 300 million light-years, and there's almost nothing there. There are also places in the universe where time and space are distorted in ways that challenge our human comprehension, like binary black hole systems, where two massive black holes dance around each other before eventually merging. As they spiral closer, they release immense gravitational waves that ripple across space-time. The first detection of such waves was made by the Laser Interferometer Gravitational Wave Observatory in 2015, when it recorded the final collision of a black hole pair. In the final 20 milliseconds before the merger, the black holes released more gravitational energy than the total energy emitted by all the stars in the observable universe during the same period. But that's not all the universe has to offer. Once you start exploring, you can come across exoplanets like Korot 7b, where rock clouds form and send pebbles raining from the skies, or Kelt 9b, the hottest known planet with surface temperatures reaching 7,800 degrees Fahrenheit, or Tress 2b, the darkest planet ever discovered. It absorbs over 99% of the light it receives, making it blacker than coal. So, as you can see, in the vast, almost incomprehensible scale of the cosmos, mysterious, fast-moving objects, strange planets, and immense voids serve.
Now see here, astronomers have recently discovered a neutron star, aka a dead star, spinning at an extraordinary speed of 716 times per second. It makes it one of the fastest spinning stars we've ever found in the universe, and it's not just about its speed. The surface of this neutron star is erupting with super powerful explosions almost non-stop. But before we dig deeper into the mystery of this neutron star, let's figure out what these stars really are. Despite its name, inside a neutron star, there are not only neutrons. A few protons survive down there too. Normally, protons repel each other since they have the same positive charge. But in a neutron star, that crushing gravity forces them so close together that the strong nuclear force takes over. It pulls them toward the neutrons like they're all part of the same team. Inside the star, things get stranger the deeper you go. Near the surface, neutrons clump into blobs, kind of like neutron gnocchi. A bit further down, these blobs link together into long chains, forming what scientists call the spaghetti layer. I'm getting hungry. At even greater pressures, the spaghetti chains fuse side by side, creating flat sheets. Think neutron lasagna. Keep going even deeper, and the lasagna eventually breaks down into a uniform mass. But even then, the structure isn't smooth. There are gaps, long tube-shaped voids that look a lot like penny pasta. So, inside a neutron star, you've got layers of gnocchi, spaghetti, lasagna, and pen. And each of them represents the mind-bending results of physics under insane pressure. Okay, I'm definitely having Italian for lunch today. Now, the recently discovered neutron star is part of a binary system, 4U 1820-30, located in the dense star cluster NGC 6624. This cluster is situated near the center of the Milky Way galaxy, approximately 26,000 light-years from Earth, in the direction of the Sagittarius constellation. The record-breaking spin of the star is extraordinary. If we take a period of not a second but a minute, it'll be over 42,000 rotations per minute. At the same time, the newbie ties with another neutron star, PSR J Graven 482446, which spins at the exact same speed. Such extreme rotation rates are rare and make these stars cosmic outliers in terms of behavior and properties. Oh wait! We can't but mention our neutron star's binary partner. It's a white dwarf, a dense remnant of a star similar in size to our Sun. This white dwarf is pretty fast, too. It orbits the neutron star once every 11 minutes. This makes the couple a binary system with the shortest orbital period ever observed. Imagine a stellar object zipping around its partner faster than the time it takes to prepare a cup of coffee. Yep, that's the kind of speed we're talking about here. This tight, rapid orbit shows how powerful gravitational forces are inside the system. You might be wondering what makes neutron stars spin so rapidly. It's something called the conservation of angular momentum. Let me explain. When a massive star collapses into a neutron star, it shrinks dramatically. Such a rapid compression gives an instant boost to its spin. It's like an ice skater spinning faster when they pull their arms inward. And the smaller the star gets, the faster it spins, which results in extreme rotation rates. In binary systems like this one, 4U 1820-30, neutron stars can achieve even faster spin rates. Their trick is to steal matter from their companion stars. This process is called theft. Haha, no accretion. The stolen matter carries that very angular momentum, which adds to the neutron star's rotation speed. The accreted material can also build up on the neutron star's surface. Eventually, it triggers powerful thermonuclear explosions. They release immense amounts of energy, temporarily making the neutron star shine up to 100,000 times brighter than the Sun. It allows astronomers to study the intricate details of these extreme environments. NASA's X-ray instrument on board the International Space Station, officially called the Neutron Star Interior Composition Explorer, and thankfully nicknamed NICER, observed 15 thermonuclear explosions on the surface of our neutron star between 2017 and 2021. One of those bursts displayed a unique pattern called thermonuclear burst oscillations. Those are highly asymmetric patches of brightness on the burning surface layers of accreting neutron stars. This pattern matched the spin rate of the neutron star and, thus, confirmed its extreme rotational speed. But wait, the best part is coming! While neutron stars are already extreme, There's another class of them